Okay, I'm back, and we are going to go ahead and get started. Now, just give you a rundown of what's going to happen. I have Monica and Jaga, and I have Lucy Wagoro, who will also help me facilitate this today. So it's going to be a live session as we speak, live in the sense that we are going to record it, and then we'll also post it on YouTube for those of us who are not able to attend today can be able to view it. Okay, it's going to be technical, interactive. If you have a question, please feel free to also just jump in, raise your hand, then jump in so you can get your question answered. So without any further ado, I'm going to go ahead and share my screen. Okay. We'll start with the introduction to Python. Okay. Python programming basics. Okay, so Python as a programming language uh, started way back in, I'm sorry, hold on one second. Started way back in late 80s, early 90s. And this was a project which was done by somebody, I believe they were still in college. Okay, so they came up with the idea and they enhanced an already existing language to make it much more friendlier, much more easier to learn, and much more better. And the person's name was Guido van Rossum. Okay, so he basically is a father of Python. So Python, as opposed to what we all maybe think we know, Python is actually not the Python as a snake or the reptile. Python was named after a popular a TV show in Europe at the time. That was Monty Python. Okay, so what would we use Python for? Okay, Python, other than machine learning and also for artificial intelligence, Python can be used for web development on the server side. We also can use it for software development, like applications, standalone applications. Okay, and we also use Python for doing calculations as in mathematics and also in science. We use Python for system scripting as in system administration and network programming. Okay. Okay. So what can Python do? Okay, that's the question. This will be able to help us answer some of the things which probably we already know, but it will go into the details of getting to know them better. So Python can be used on a server to create web applications. Okay. Python can be used also, let me go ahead and shut that off. So Python can also be used alongside software to create workflows. Workflows, when we say workflows, you can use it as a model for a main program, but since it's easy to learn and easy to use, it will be able to put together for us stuff in the workflow so that we can be able to look at the bigger picture. Okay. Python can connect to database systems. Okay. The advanced programming class will be able to attest to that. We've so far used Python to connect to SQLite. We've used it to connect to MySQL. We've used it to connect to Mongo database. You can use it for connecting to Oracle. You can use it for connecting to Neo4j and so many other databases. So it has the API. API means application programming interface, and that enables Python to talk to third-party systems. Python can be used to also handle big data, like the big data, very large data sets, and perform very complex mathematical calculations. We can also use it for rapid prototyping. If you need something done like within a short period of time, Python is a language to go for. It makes work easier without taking a toll on you in terms of resources and also in terms of like the money you need to pay. to just make it happen. And you'll find that most of the companies, of course, they always want to go on the lower side of costs, and that makes Python a very clear choice, because to learn it, it doesn't take long, and to be able to produce something tangible and something within a specified budget, it also doesn't take long. So people, most of the companies, they tend to go for that, and also people are learning Python a lot. Okay. Now, Python works on different platforms. And I know amongst us here, there are people who are using Mac. I'm using Mac. I also use Windows. I have Windows, and I also use Linux. So I have Python in all those three languages, or all those three operating systems. And that makes it very popular. Also, remember, Python is free. The fact that you can download and install, you don't have to buy it, makes it much more even easier. There's something which you also need to realize. Python can run on what we call Raspberry Pi. Raspberry Pi is a very small computer. Mostly they use it in colleges for like running very small projects like robotics. And if you go into really detail of Python programming, you'll be able to learn a lot about that. So Python is very robust, and it's very portable. It has a very simple syntax similar to English, as you all know already. Okay, has the syntax that allows you, the developer, to write programs, okay, with fewer lines of code. Okay, if you are to do the same line of code in Python, compare that in Java, it's going to be a whole lot of a difference. So Python runs on an interpreted system, or the interpreter. Some other languages like C, C++, Java, C#, and all those, they run on what we call compiler. So Python, that means Python run, when you execute the program, it runs line by line, line by line. So you put in your first name, you have to press enter. When you press enter, it gives you the output. And then you put the next second name, then you press enter, then it gives you another output. So that's what we say Python has an interpreted way of doing things. And that does not mean you cannot compile it. It can be compiled, but just know the fact that it's easy to learn, it's interpreted, and it can be easy to prototype in. That makes it a big deal. Okay. Now, Python can be treated in a procedural way too. We can make it like a very old way of doing things in a procedural way, like you put programs together, then we program them like in blocks. Python is also object-oriented. Okay, that means we can just declare functions and then we call them. Okay, some things which are good to know about Python. The most recent major version, okay, is Python 3. For a long time, we were running on Python 2.7. And I wouldn't be surprised that lots of companies invest a lot of money in Python 2.7, and they're still in that. There's a lot of changes which came with 3.0 or 3.x, which was not in 2.7. So let's say today you're lucky, good enough to master this craft, and you get a job. By the time you get a job, you might get a job for like a government institution. Most likely be running some of the code in very old legacy system. And that will be like 2.7 or 2.6. But most likely the main and the major one, which is now optimized, will be 3.0. Okay. Now in this class, we basically will be concentrating on 3.0. And that's what I would really personally encourage you to concentrate on. But don't assume that there's nothing like 2.7. Sometimes somebody or somewhere where you might be able to go to work at might be able to give you that aspect of it. So you really need to have that in your mind. Okay. Python was designed for readability and has some similarities to English language with influence with mathematics and science. It uses new lines to complete the command as opposed to other programming languages which often use semicolons. So in Python, we use indentation. We indent. I know you probably, during the process of running some of the programs, you were able to get an error because you did not indent. Okay. When you're doing your indentation, just make sure they are very consistent. That way you avoid a lot of errors. Okay. It's a big deal. So is it worth to learn Python? Yes. And that's probably why you are in here. Maybe somebody who read somewhere that Python is very important. Research and reports reveal that Python is one of the most preferred language in the 21st century. Okay? The reason behind is its simplicity, the huge community behind it, and also a lot of built-in libraries and packages which make it very robust when it comes to machine learning, artificial intelligence, and data science. Okay? So it's a big deal. So if you're in this class, I would really encourage you try. I know it's drinking from the fire hose, but try as much as you can to see if you can get something out of this class. If you have to come and do it again, maybe one day, at least you have some basic knowledge. But also at the same time, you probably also want to do a lot on your own in terms of read, and you also test the programs. I have a lot of examples, and also you can get a lot of other examples online to do those. In your Kunjis, that will come very handy to help you. Okay. We have listed down some important points why we should know Python in 2021, of course. Okay. High package salary. It will give you a good starting salary. Okay. Easy to learn, execute. Okay. And also leading language in data industry, the data science. Machine learning is a big deal. Artificial intelligence, the main thing now. Like they say, data science is the sexiest job in the 21st century. So if you have the skills and you're lucky enough to get a job in there, they will probably give you a very good package to start with. So there's always that versatility and career advancement. You know it, you can easily move up in the ladder within the company or move outside to another company just because you're in demand. Okay. Application and job roles, like we have so many companies. Okay. Now most of the companies are either doing software development, game programming, 3D graphics, big data analytics, artificial intelligence. And we are talking of major companies like Facebook, Amazon. We're talking of even some government agencies like NASA. Talk of even the military. Talk of so many of them. I cannot even name all of them, but it's a good thing to know. Okay. In addition, that it's very portable and it's extensible. Supports a wide range of applications. Okay. So all these are in your notes. Okay. Readability, easy to learn, free, cross-platform, memory management, exception handling, open source. It's all good. In addition to that, okay, we answered some of the questions here. Okay. But I would like to jump to how it all started. There are so many other languages which started like a long time ago. We have different generations. The first generation ever was machine language, which is ones and zeros. And then came the assembly language, and then the third generation language, which are like C programming language. Now Python will most likely fall in between the third generation, fourth and fifth generation, because it's imperative language, it's object-oriented, and it's logic language. So if you know Python, you're basically covering like 3-4 generations. And those are some of the advantages you probably need to consider. Now, if you look at there, it falls under procedure, because in Python, you can program in procedural language. You can also design programs in object-oriented. It's also fourth generation. It also falls under fifth generation, which is AI techniques, inference like in statistics. It's also for neural networks, which is also for for artificial intelligence. So those are the advantages we have, okay? And of course, all this will be in your notes. And I'm gonna go ahead and pass over the mantle to Monica. Monica, you can take over and get us into variable names. Thank you.
Hi. Hi everyone, thanks for joining. And so George, I'll go ahead and share my screen.
Go ahead and take over.
All right, so I'll be talking to you about variables today. Can you all see my screen?
Yep. Okay.
I need to dock this thing.
Yes, we can.
All right, thank you for the thumbs up. All right, so I'll be talking to you about variables today, and I want to mention to you that variables are the core concepts of Python programming. And I say Python programming because it's my first programming language. I don't know any other.
Monica,
Yes.
can you put on the display like so everybody can see? See that thing? It looks like a computer screen next to the slider.
Computers.
Next to the slider is that thing like display.
Next to the slider.
Down.
Do you want to point it out with your annotation?
Okay. So down at the bottom, you see where the slider is at?
Yeah.
Okay. To the left, there's that thing which looks like a...
Oh my God. I can't see it on mine.
Okay. Can you put a slide? Can you do it on a...
oh, like a slideshow, you mean?
Yeah.
Or...
Yeah,
oh.
sure. So it can be bigger. Yeah, that's good.
How do I get this thing out of here? Oh.
I think it's good now.
Okay, it's good now? Okay. All right. So you'll ignore everything else that you... Okay. So yeah, as I was saying, yeah. So variables are one of the core concepts in the programming language. And I say programming language, Python programming language, because it's my first programming language to learn and I love it. So you might be wondering, so what are variables? So variables are reserved memory locations to store values. And what that means, when you create a variable, you reserve a space in the memory for its storage temporarily. And as you probably know by now, I'm sure a few of you have done your homeworks, or if not all, there is no command for declaring a variable. You just pick a name and give it a value that becomes your variable. So a variable is created the moment you first assign a value to it. And if you can remember the first assignment, I believe it was name that you declared as a variable, and then you call the function input. So I believe by now everybody has created a variable. So on my next slide, I'll give you a little background of what exactly happens, if it can even move. Hold on. All right, yeah. So assuming I went and created a variable by the name of students count and gave it a value of 1,000. So when you run this program or this piece of code, the interpreter will allocate some memory and store the number 1,000 in that memory space, which will have the variable students count, which references that memory location. So if you wanna, so this is another way to think of it. So a variable is just like a label for that memory location. And you can use this variable or label anywhere in your program to get access to that memory location and the data stored in it. So like in this case, if I ever wanted to retrieve that 1,000 value that I've assigned to the students count, all I need to do is to declare the variable and then I go and print the variable. And that's why you see on the left side of my screen here, that's what, I mean, the right side, that's why you see the 1,000. So moving along, you might be wondering, so what kind of data can you store in a variable? So So far, I know we have stored, or from the 3 assignments that have been provided, we've stored strings and I believe numbers, but let me just go down the slide. So you can store numbers, and there are 3 types of numbers that Python can store. So there's the integers, and when we talk about integers, it's any whole number, and it can be negative. 0 is also an integer, and anything positive, like a 6, name it 0 to 9, or anything below 0. And then you can store floats, which are 1.9. This is what we normally call decimals in math. And then there is also complex numbers. An example is like 2 plus 3j. And then in a variable, you can also store what we call Boolean, and this is true or false, which in English is pretty much yes or no. And then also we can store a string in a variable. And how do you define a string? Like, how did you define your name? So you can define a string using a single quote or double quote. And you might be wondering, so why do we use single quotes sometimes? Sometimes we use double quotes for strings. So it's because double quotes make it easier when you want to include apostrophes. Like if you want to say your statement is equals to don't enter here. So there is the apostrophe between the N and the T. If you put double quotes, then that will be easily assimilated and printed as you expect, as opposed to whether if you had only one or single quotes around it, then you would need to do an escape character. And then you'll know more about the escape characters as we go along. So just to give you examples, so these are some of the variables that you can store. So like we have an integer right here with 1,000, and then we have a float, 4.99, which we said is a decimal, and then our Boolean, which evaluates it's true or false. And if you notice, true is capital T, because it's that is how Python defines it. If you put a small t or all capital T, then that's interpreted as something else. And then there is also the string, which in this case, course name equals to Python programming. So moving along, in my next slide, I'll be mentioning a little bit about variable names. So there are best practices that we adhere to when we are declaring variable names, and I'll mention a few of them. So like, for example, it must start with a letter or an underscore character. So a variable can never start with a number. And then there are some keywords. I believe most of the languages have keywords. I have done a little of SQL, so I know there are SQL keywords, and so does Python have its own keywords. You cannot use those in your variable. So like you can't call your variable while equals to when I was there, or something like that. And then special characters, you cannot use special characters in your variable names, even though there is an exception to the rule. You can use underscores as to start your variable name. And if you have a name or a 2 names variable, like the example that I gave, we had students count, so you can separate the 2 using an underscore. And then variable names are also case sensitive. And what do I mean by that? So if you look at this, and I'll just use my annotation right here. So if you look at this line down here, this that says different, if you declared this variable and declared and called this one, it will give you an error and tell you that that variable is not declared. So what I mean by that, SPAM, all small letters, and then SPAM with S as a capital, and all caps SPAM, those are 3 different variables. So case sensitivity, you wanna check what you are, how you're naming your names, and when you wanna call your print function, you wanna call the print function using the same name that you gave your variable. Now, moving along, so there are also some other, I wanna say, prettify or beautify kind of best practices. And those are, you wanna give your variable names some descriptive and meaningful names. So for example, students count, you can almost guess that that is the number of students that you have in a class. If I called it something like SC, you wouldn't really know if I'm talking about South Carolina or, you know, Saidia Church. You never know. So you want to give it something very descriptive. And then there is also the lowercase. So it's best practice to just give them lowercase, all your variables, but not necessarily. And then whenever you're creating your variables, put a space between your variable name and the value. Meaning, I don't want to write something like, and I can just put it here. So what they're saying by that is, so X equals to 100 is okay, but X equals to 100 with spaces in between is better when somebody is trying to review your code or at least look at your code. So with that, I'll take you next to the next screen and show you or tell you a little bit, a few variables, tips and tricks. So number one, you can assign one type of data to a variable and later reassign another type of data to the same variable. And I've given an example. So like here, our X can be 5, and then I can decide, you know, variables are always changing. I can decide, oh, now I want my X to be earthquake Wanjiko, or a few days later or a few minutes later, you can always assign your variable X equals to a list, which is what you have here. And George will talk more about lists. And then another tip and trick, Python allows you to assign a single value to several variables simultaneously. So what this means, if you know that A, B, and C, and F are all going to be 19, there's no need of writing or typing A equals to 19, B equals to 19, C equals to 19, F equals to 19. This is a shortcut, and you can do that and you can print them one by one. And I'll be showing you some of these in code so you can see exactly what I'm talking about. And then you can also assign multiple objects to multiple variables. So what this means, A, B, and C are 3 different variables. You can just do, I guess, one time assignment. So what means A is assigned to 2, B equals to 3, and then the value of C in the memory is Hakuna Matata. All right, so with that, I wanna ask, do we have any questions of variables before I get onto the operators, which is the next topic? I will take that as a no. And I hope our diaspora folks are still awake. So I will go to operators, and this will be a little interactive because I'll also be doing some things on the terminal so you can see what exactly we are doing. So you might be wondering, so what are operators? Operators in Python are used to perform operations between variables. So we also refer to operators as constructs or special symbols that are used to manipulate values of the operands, which are the values in an operation. Now, so, and just to give you a more pictorial view of what exactly that means. So on the left side, you have an operand, and then you have an operator, and then on the right side, you have an operand number 2. And what you do once you use those 2, you get a result. So an example of an operand here, assuming you had put your value of X as 2, and then your value of operand 2 as 5, and then you put an operator plus, it will give you a result of 2 plus 5, which is 7. And we'll see that in more details. And then, so with operators, what are the different types of operators? We have arithmetic, and as the name suggests, this is all mathematics for all of us who love math. And then there's assignment, there's comparison, there's logical, and then there's membership, and then there's identity, and then there's bitwise. And on my next slide, this is just them listed, and we'll go over each one of them one by one, so at least you can get an idea of what exactly each one of them is. So what are arithmetic operators? So these are used with numeric values to perform common mathematical operations. So we all know about additions, subtractions. We probably have one time or another multiplied and divided. And then there is also the modulars, exponentiation, which we call power of, like 5 to the power of 2 means 5 times 5. So you're raising it to this to 2 or yeah. And then there is the floor division. So with this, there is also a note here that I have written. There is an exception to the addition operator. So as it said here, so operators are used with numeric values to perform common mathematical operations. So with the plus, you can also use it with non-numeric values. Like we use it for concatenation, and I'm gonna show you that in a little while. So those are the arithmetic operations. And I know we are very familiar with at least the first four, and I will give a little demonstration on the modulars and the floor division. So the next type of operators are assignment operators. And what do these do? So they're used to assign values to variables. So which ones are these? So we have the equal sign, plus equal, which is, as you can see here, so the equal sign we already did, like we declared the name variable and then we submitted our first assignment. So plus equal, this is an example. And this, just because it has the plus equal, don't let that scare you. It's the same as just doing the plus, but to look more like a programmer, yeah, you can write it this way. And then there is plus, minus, and then there is multiplication equal, and then division equal, the modulus equal, the floor equal, and then the exponentiation equal. Now, with that, let me just flip over to my notebook here so I can show a few of those. So when we talked about variables, one of the things, and this is just a by the way, and it's nice to have, and I know George will be sharing this. So we said one of the rules that we have, you cannot really list or use keywords, some of the Python keywords in your code. You may wonder, what are the keywords? So this is a handy dandy piece of code that you can use for just running, and it will tell you all the keywords that you have in Python. What that means is you can't have a variable name called await or assert or and or true, on and on. So moving along, this is just a description of the tips and tricks that I mentioned. Like if you know all these values are gonna have the value of 19, why don't you just assign them at the same time? And then, as you can see, when I run this, it prints all of them as 19 because that's the value you've assigned. And then the other thing that we said is that the kind of values that you allow in, the numeric values that are allowed to be stored as variables, numbers, we can have whole numbers. And then we also have the floats, which I have as 2.0, and this is how you write a complex number. So for now, and for the purpose of running our code and seeing what we just talked about, I'll just go ahead and print some of the variables that I have here so that we can see exactly what we are doing. And another one here, and I'm sure you've seen that in the notes, or you will see as we go by, you can always go and check what type is your variable. Like this one, we said it's a complex number, so it gives us a complex. Now, the reason we are here is because we wanted to talk about arithmetic operators, right? So we said the arithmetic operators are used with numeric values to perform common mathematical problems. So we've already declared our X as 5 and Y as 2, right? So I'm just gonna come in here and print so you can see what it does. So I'm using the plus and then the minus. I'll just use the same cell. So 5 minus 2 is 3. And remember our X is 5, Y is 2. Just keep that in mind. And then who remembers any other mathematical operators?
Multiplication.
Multiplication, yeah. So 5 times 2, we should expect to get a 10 here. And then we did. Then I'm going to talk about the exponentiation, which is the power of, and I'll also talk about the modulus and floor, which I had to research myself, even though I did math. So exponentiation. So what we are doing, we are raising 5 to the power of 2, right? So the expected answer here is 25, and that is what we are getting. So now let's do the modulus, okay? So 5 modulus 2, when you run, you get 1. And you may wonder, where did we get that? I'm going to use my annotation here and do it the way I was taught. I'm 844. If you're from Kenya, you know what that means. So this is how I was taught to do math. So 5, divide by 2. This is how, so it comes in here 2 times. I mean, 2, and then you get a 4 here. And then there is this 1. We used to call that 2 remainder 1, but this is the modulus. That's why we get a 1 here. Now, there is another one. So is everybody clear with the modulus before I go to the floor?
Yes.
Okay, so I'll clear that. And then there is a floor division, which is tan, those two, I want to call them forward slashes, but I confuse forward and backslash, but it's okay. So the answer here is 2. So how do we get to the modulus? I mean, the floor. So the floor, I'll do the same thing that we did, and maybe this time I can get a number like 7. So 7 into 3, I'm sorry, let me do with the same number so we can know how we came to that answer. So 2 divided by 5, right? So it is on here 2 times, and then we get the 4, and then we get the 1. So this is our modulus. This 2 here is our floor. I guess it's the one that, yeah, floor is the 2 because it's the first multiple, or I don't want to misquote it. So yeah, that's the modulus, I mean the floor. And so on to that, now we also talked about our assignment operators, and let me just switch back here so we can remind ourselves. So these are the plus, I mean the equals to, the plus, equal, on and on, everything that we've done for arithmetic, only that we are putting an equal. So how do those work? So assignment operators, they assign values to variables. So like we assigned your name to a variable. So in this case, we are assigning x equals to 5, right? And then we want to see, so what is, so x plus equal to 3, and then we print the value of x, because what we are doing, we are taking the original x and then we are adding 3 to it. If you remember from the slide, we said x plus 3 or x plus equal to 3 is the same as x plus 3, okay? So now the answer here should be 8, the last time I did math, yeah. And then same case, if we do a minus, then it's gonna be 5 minus 3, which is 2, on and on. And you can practice this on your own and it'll be, yeah, you can see what I mean by that. Now, there's also the note that I mentioned about the int, like the plus sign or the, what do you call, the arithmetic operator plus. It is used to add numeric values or mathematical calculations, and we can also use it for strings. And what do I mean by that? I want to, and what does it do to strings? It can be used as an arithmetic function as well as a concatenation function. So this is an example of a code that I have here. And I'm sure by now everybody has done the input function. So can anybody tell me what you think the answer to this will be? Actually, let me do this. Let me run it and then I'll give it a number. So my number 1 is 10 and number 1 is 20, right? I mean 10. So if you look at what I'm doing here, I'm getting a sum of it. So sum equals to number 1 plus number 2, right? Can somebody tell me what they think the answer to this will be? Anybody want to give a shot?
30.
Can teachers try?
No, teachers cannot try. But yeah, Brenda, good, 30. Let's see what the answer is.
2010.
2010.
Mm-hmm.
So what I wanted to teach or to mention about when we are doing the plus that involves integers, plus you can only concatenate or use a plus, or you can only concatenate like terms. Like if it's a string, you can concatenate with another string. If it's an integer, you can concatenate with another integer. Now, you may argue that what we need to do is to convert this into an integer, okay? So that when I get my values, and this may look a little Greekish, but this is called conversion, and I know George will touch more on this. So now we have our integers. So guess what? We should get a 30, right? We're gonna use the same numbers. So let me run this again. And 20 and 10 and 30, right? Wow, guess what? You can only concat string, not int, to string. Remember what I just mentioned? You can only concatenate like terms, right? So what are we gonna do? So we have an integer here, right? And we have integers here. So this one is printing fine, okay? But the issue is here, because if you look at this, when we talked about our strings, this is a string here, but we are trying to concatenate with 30. So it's like adding Brenda plus 30. The answer to that is an error, or this kind of an error, right? So what we do in here, we come and make this a string, okay? And when I say string, this is another new concept, but George will mention about that. It's about conversion. And you may be wondering why I even had this note here. So a point of reference, anything that you declare using the input function, if you don't go ahead and put a converter, like the way I put int, it will come out as a string. The same thing is, anytime you use your print function, if you don't go in like I've done right here and do a conversion, it expects to get a string or an error. And of course, you're gonna get an error. So now when we run this, things will be a little different, because now I think it's gonna like it. And yeah, there's our 30. So all this today, you can use the plus sign to do your math and also to concatenate, but then you have to do some conversion in the mix. It just won't come across as easy, but that's about Python. So I will go on to the next set of operators. Oops, never mind.
Monica, I'm sorry.
Oh, yes, questions. Yeah, sorry.
Yeah, I have a question on that.
Yes, babe.
If you can go back to the code. Sorry. So I see where before you converted the sum into a on the print what is it, on the print function?
Yeah, number 5.
I'm wondering why did you have to convert? Because I guess I'm confused why, if the sum is already equals to the variable num1 and num2, why do you need to convert that? Okay. Yeah, sorry.
Sure. Okay, so what we are doing, and I'm gonna write the line number here. So in line number 4, right?
Right.
The sum, okay, should equal to our 20, and these are the values that I had input, right?
Yeah.
Our answer should be 30, okay?
Yeah.
But there is nothing in number 4 that is telling us to give us an output, correct?
Right.
You know, to get an output, we have to go and do a print function. So what I'm doing in my print function, remember, anytime that single quote comes, that tells me it is a string, right?
Right, okay.
Then I'm telling a string, Mr. String, go and concatenate with Mr. Integer or number 30. Let me write 30 because that's the answer, right? Go concatenate with 30, which is an integer. And what we said, you can concatenate as long as you're doing like terms. If you're concatenating strings, if you're concatenating, you're either concatenating two strings or two integers, or you have to have like terms. So that is why we had to go and change this, this 30, which is coming in the variable called sum. We are converting it into a string. So it doesn't look at this number as a 30. It's gonna look at it as a 30. If it was actually to look at it, it would be something like this behind the scenes, like a string, it's making it a string. So that's why we had to do this. Did that answer the question?
Yeah, I did. Yeah, thank you. I appreciate it.
No worries. Do we have?
I do have a quick question, Jemima.
Sure.
Yeah, I have a quick question. Can you hear me?
Yes, I can.
So is it the same as just saying print sum without having like addition and converting it to a string?
You know what? Yeah, we are all here. Let's do this. That's your question, like right? Can we just print sum? Yes. Let's see. Yeah, right there. Because you know what? That's an integer by itself. There is no concatenation with anything else. The one game spoiler here is because we want to, at least whoever is looking at this, we want them to know what is it that Monica was even trying to do, right? She was trying to get the sum, right? Because if you see a number 30 here, you won't know what I was trying to do with number 1 and 2, right? Nums 1 and 2. And these are some of the things that we mentioned about beautifying your code. So this is the spoiler, but yeah, as you saw, when we remove this here and the plus sign, that and that, we just do the sum, yeah, it gives us a 30. But assuming somebody walked in the door, like I know there are some people who are joining the call now and they're like, okay, so where did that 30 come from? If they look at it and they see sum here, they'll be like, oh, we're trying to add things together. So that's why.
Okay.
Yeah. So,
I have a question, Monica.
Yes, sure.
So in number 1, I'm trying to climb a tree from the top here. And the number 1, I would like to just explain to me briefly when you say number 1, which is a variable, I understand that. And then you have the int and then the input. You just explain the brackets and what each thing means after the equal sign, the int, the input, and the...
Okay, sure. And what I can do, I can, and this is just another thing, whenever you want to comment your code so that it doesn't run when you run or give any output, you just put the hashtag. So this is your question. And let's say what we did in the, okay, actually, let's say we even have number 3, right? Number 3 equals to, so input, right? Oops, never mind. Input is a function that allows us to input a value. So like I can do a variable both ways, right? So I can put and say num3 equals to 30, right? But what if you want to make this interactive? You don't even know the value at the time, you're gonna know it later. So that's why you put the input, okay? And then you say something like enter num3 value, okay? Now, there is also this int here that you are asking about, right? That you referenced.
Yeah.
So when I explain this part here, whenever you do the input function in Python, what it does, whatever output that you're going to put here, assuming we will, okay, if we run this and we put 30, okay, this is a string. It stores it as a string, okay? Yeah. But for us to be able to add it, how do we want to store it? Because if we do 30 and then assuming we have another number 4 here, and we are giving it a value of 40 and our intent is to add them together, guess what our output is gonna be? It's gonna be 30, 40. Because this plus sign, it tells us, okay, take that string. It's not really gonna add it, it's gonna concatenate it. And that is the reason we wanna do an int. Int is just integer. Oops, where did I go? Sorry. So we put this int function, okay? So it makes it an integer. It's like converting it on the fly. Did I answer that question? And you know what? Anytime you want to know something about this, so you can use your shift tab. Come on, shift tab. Never mind. Oh, is it all tab? Never mind. Lucy or George, what do you use to get the notation on this? I think it's shift tab, right? Oh, hold on.
Yeah, shift tab.
Oh yeah, I guess it's because I hadn't clicked in. So you see, like now if you want to see any annotation on the int, right? Integer converts a number to a string or string to an integer, right? So we are doing this second part. Ours is being stored as a string, but because we are putting the int, it converts it to an integer.
Yeah.
Is that?
Yeah, that's good.
Your question? Okay, cool. Do we have any other questions?
Yeah, good. How much more time do you have, Monica?
I have the logical operators and this. I don't know, time to.
Okay. Okay, we're gonna wrap it up so can they lose.
Okay, yeah, we are gonna skip through this. So, and then maybe we can follow up with questions on the side. All right, so we talked about arithmetic and those are good questions. Good, yeah, so we can all learn together. So the next one is comparison operators. So with comparison, we are trying to compare, is X equals to Y, or is it not equal? Is it greater than, is it less than, is it greater or equal to, right? So, and what they are doing, so they're also called relational or conditional operations, meaning you check a condition. Is it less than, or are you older yesterday than you are today, or vice versa? And then I'll just show this very briefly because we are running out of time. Okay, so comparison operators. So as we say, they compare values and these are the signs that you use. So if you remember here, we had declared our value of X as 5 and Y equals to 2. And one thing about these comparison operators, they don't give you back a value, they give you a true or a false. So remember, in the memory, our computer has 5 as X and 2 as Y. So it's asking, is 5 greater than Y? Or is Y greater than 2, right? It's false, right? But if we did the less than, which is the other operand, then that would be, so 5 is less than, yeah, sorry, 5 is less than 2.
The cell again.
I'm sorry? Oh yeah, I think I need to restart the kernel.
Restart the kernel or something, yeah.
Okay, yeah. And this is something that you see, especially when you're running Jupyter, I mean, the notebook. Yeah, it kind of runs out of memory. I think I did.
Should tell you something. You love me.
Yeah,
No,
and
I am amazing.
I think
Please
we
stop
hear
talking
some
about
background
yourself.
noise.
That's our bread and butter now, sister. I just need to tell you.
Lani, you
My
probably
under was fine, so shut up. Shopping.
Okay.
Right now.
All right, and then you can practice
Dresses
this
to
on
buy,
your
and
own.
hats to buy, and
Somebody has
shoes
a
to buy, and purses to buy.
it's okay, I'll take care of that.
Okay. All right. So, sorry. Okay. So now we talked about the comparison. So next in line is the logical operators. And these are used to combine conditions. So we have the and, the or, and the not. So the and returns true if both statements are true, right? So if you declared your value of X as 5, okay? And then you're trying to see, is it less than 5 and less than 10? If the statements that you're trying to compare are both true, then you get a true. The or returns true if one of the statements is true. And then if you're trying to get the reverse of it, you would use the not. So reverse the result, returns false if the result is true. And I can share with you the code on that, and then you can practice on your own. And then we have the identity operators. And these are used to compare objects, not if they are equal, but if they are actually the same object with the same memory location. So we have the is, it returns true if both variables are the same object. And then we have is not, which returns true if both variables are not the same objects. All right, so our next set of operators are called membership operators. And these ones are you a member or not? Are you in this class today or not? So assuming you had a basket with apples and bananas and oranges. So if you are to check if the basket has apples, the answer would be true. So it returns true if a sequence with a specified value is present in the object. And then not in, so we say there is apples, bananas, and oranges. If you go in there and try to look for pineapples, they are not there. So you would get a false. So that's about the operators and the variables. And I'll give it over to Lucy. She'll cover the next topic. And if you have any questions on those operators that we spoke about, you can follow up on the Kamukonjis and we'll take it from there. So thank you so much for your time.
Thank you. Thank you, Monica.
Thanks, Monica. That was so good. Thank you.
Thank you.
Monica, that was great.
Oh, thanks.
I loved it. So I'm going to take us on bitwise operators. Allow me to share my screen. Okay, right. So my name is Lucy Wagoro. Most of you know me as a Fidambuge. So it is also good to clear that. Monica has explained about arithmetic operators, assignment operators, comparison, logical, membership. And I want to introduce that bitwise is also one of the operators. I want to start by explaining some two things. I'll give a few backgrounds before I discuss on what bitwise operators are. So first thing I'll talk about is to explain that whenever we are doing an operation, we are dealing with two things. One is an operand, and another one is operator. So what is the difference between an operand and operator? I have 5 plus 6. Then 5 and 6 are operand. And then plus is an operator. So therefore, an operator operates on an operand. So I want that to sink. When we are talking about bitwise operators, we are saying that bitwise operators are used to change individual bits in an operand. So basically now we know what operand is. And then we are saying that bitwise operators are used to change individual bits in an operand. It is good to also understand what bits are. I will say that every other human being, every other person knows one type of numbering. We have different numbering systems. So in school, what we were taught in maths was base 10. So we have base 10. I'll give this background before we talk about operators. Let me lift this. I hope you're able to see what I'm showing. So we have base 10, we have base 2, we have base 8, we have base 16. Base 10 is what we are familiar with. This is a numbering system that contains 10 unique symbols. So we are talking of numbers from 0, 1, 2, 3, 4, 5, 6, up to 9. So when you look at this, you are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that means that there is no any other unique symbol that you can use. If you are counting and you start from number 1 to from number 0 to number 9, then the next number you will go to is a number 10. So number 10 will just be combining a 1 and a 0, and then number 11, a 1 and a 1, but you will not get any other unique symbol apart from those symbols. So base 10 contains 10 unique symbols. Even if you count from 0 to billions and trillions, you will only be combining these values. Base 2 contains only 2 unique symbols, 0 and 1. So even if you are counting from 0 to a trillion, you will just be changing between 0 and 1. So you will be saying 0, 1, 1, 0, 1, 1, 1, 0, 0. There is no day when you are counting in base 2, you will mention a number 2. You will just be counting from 0 to 1. Base 8 has got 8 unique symbols. That is from 0 to 7. You cannot count 8. It will be 0, and when you reach 7, you do something else. You don't go to 8. And then base 16 will be running from 0 to an F. So you go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So it is like, it is alphanumeric. So you have 16 unique symbols. So bits are in base 2. When we are talking about bits, then we are talking base 2. There is no day we are going to mention a number 2, a number 3, a number 4, and write it as that. We only use the symbols 0 and 1 to explain on that. I'll do a little conversion between base 10 that we know and base 2, but I'll just use the very simple ones, because then you will not be able to understand what bitwise operators does. So we can always do a conversion between all these. If I have a number in base 10, I can change it to base 2. If I have number in base 2, I can change it to base 10, I can change it to base 8, I can change it to base 16. And maybe during your own time, you can Google that and see more on how you can do it. But I will just give a few conversions. I want to just show how I can convert from base 10 to base 2. So for me to convert from base 1 to, from base 10 to base 2, then for instance, I will want to, I can have a number 3. and I want to convert this 3 so that I read it in base 2. So what I do is I use what we call short division method. So I'll put my 3 inside and I put my 2 outside because I am converting it to base 2. So I go like 2 goes into 3 one time. I keep the remainder. So 2 goes into 3 once, remainder 1. And then 2 goes into 1, 0, remainder 1. So it is the one that, it is the remainders that I read, but I read them going up. So I will have 1, 1. So 3 base 10 changed to base 2 is 1, 1. So normally we write a 2 down here to show that this is a base 2 if we were doing maybe calculation. So that is very important. So now let's get back to our bitwise operators with that background in mind. Bitwise operators, now we have explained what they mean. And I'm also saying that we have several bitwise operators. So we have an AND, which sets each bit to 1 if both bits are 1. We have an OR, sets each bit to 1 if one of 2 bits is a 1. We have XOR, which sets each bit to 1 if only one of 2 bits is a 1. And then we have a NOT, which inverts the bits. We have this, we call it 0 fill left shift. And then we have this, we call it signed right shift. So I'll start from the downer ones, the 0 fill and the signed right. So the left shift, this one, what does it do? It returns X with the bits shifted to the left by Y places. So I have X, assume I have 3 inside my, my X, and I have a 2 inside my Y. And then I am saying that it returns X. So it's like it is giving us the result of X as it returns X with the bits shifted to the left by Y places. So so bits number 3 is written like that. And then we are told that it shifts, it's like pushes this, shifting, carrying this and pushing it to the left by Y places. And our Y is at 2 in the example that we are giving. The new bits on the right hand side are zeros. So it will be like pushing it like that. It adds 0 to the right so that it pushes that twice. So the result for our X here is a 12, which is 1, 1, 0, 0. If you want me to take you through conversion from base 2 to base 10, then I'll do it later and not today. But this should be a 12. 1, 1, 0, 0 is a 12. So I can just shift. I just want to shift so that I show this very fast as we move. Sorry. So I had a 3 and then I'm left shifting twice. So I get a 12 and that is exactly what you saw. I have a 3, I'm left shifting twice. So I push the 3 and then I add the 2 0 and I get a 12. Right.
Are you sharing the code or the PowerPoint?
Yeah, did I share the code?
No, we still see the
Oh,
PowerPoint.
sorry for that. I thought I did. Let me just stop sharing so that I share it. So that I share the desktop. I'm sorry for that. Yeah, sorry. So you're able to see my code now?
Still loading.
No.
It's still loading.
Oh, sorry. It loaded?
Yeah, it is loaded now.
Yeah.
Thank you, thank you. Thank you for that. I assumed that I had shared. So 3 left shift 2 gives us.
Yet again, Lucy. Okay.
Sorry, are you able to see it?
No.
It's a wide
Just
screen.
seeing creepy things.
It's back now.
I don't know why that happened.
You can share the whole screen and you don't have
I did.
Okay.
I don't
What
see
are
it on my screen. I see it on the far right screen. Like a little window.
Nancy, what do you see?
Oh, I'm seeing the code, like double click to edit.
Yeah, we can see it now.
Yeah, we see your call up, Lucy. I'm good, and I think a few others.
Thank you, thank you. So we are having 3, and then left shift 2 gives us a 12.
Okay.
So it's calculating bitwise, not like in decimal or in base 10. And then now that explains what left shift does. And then now, what does the right shift do? The right shift operator returns X with the bits shifted to the right by Y places. So the left shift shifted to the left by Y places, and then now the right shift is shifting to the right by Y places. So this is how it is done. On the background, this is what happens. So I have my 3, I'm going to use 3 and 2. So I have 3 and I am right shifting 2 times to the right. So we all now know that our 3 is 1, 1. We actually proved that, right? So now we want to shift it to the right. So somebody may think that just the way we did it in left shift, you would do this. But that will give us still a 3, right?
Yeah.
Somebody talking?
No, just continue this.
Thank you. So that will still give us a 3 because we haven't done anything. We haven't done anything. Let me use a bigger number because this will actually, let me just leave it at that. So this will do nothing because the zeros on the left normally mean nothing. Just like if even in base 10, if I write 0, 0, 0, 0, 3, I just mean 3. But the moment I start adding zeros the other side, then I mean something. If somebody gives you money of the value 0003, you will know you will carry 3 home. But if somebody starts putting zeros on the other side, then you know values are changing. Same way when we are talking in bits, any zeros on that far left mean nothing. So this means we haven't done anything. So what right shift operator does, it kills the values to the right as it shifts. So it will delete this 1 once and then delete this once, and we remain with a 0. So if you check that again, in our calculation, sorry, I'm trying to shift, right? So if again we check that, then I'll bring a new code and I'll say 3, now right shift twice. And if I run this, I'll get a 0. That is proven. The next thing we are going to do is now to check on the AND operator. X and Y. So what does AND do? Does a bitwise AND. Each bit of the output is 1 if the corresponding bit of X and of Y is 1. Otherwise, it's a 0. I'll bring my annotation so that that gets home. So we are saying, if I have X and I have Y, then I'm saying each bit of the output is 1. So for me to get output 1, it will only happen if the corresponding bit of X and bit of Y is a 1. Otherwise, it's a 0. So if I have my X as a 1 and I have my Y as a 1, and then I do an AND. So I say X and Y. I didn't type X. I say X and Y, and Y, then my result will be 1. So that is if my both X and my 1 is like that. So basically, I'll bring something that maybe we call truth table to just show that. So on the truth table, I'll draw the possibilities. So I can have X, and then I have Y, and I have the result, which is now X, and it is not easy drawing that. And then I have a Y. So separating this, the possibility is we can have our X as a 0 and our Y as a 0. We can have our X as a 0, but our Y is a 1. We can have our X as a 1, but our Y is a 0. We can also have a possibility of having X as a 1 and Y as a 1. So when we are using the AND bitwise operator, then in case we have X as a 0 and Y as a 0, X and Y is a 0. Here it is a 0. Here it is a 0. And here it is a 1. So in our example that we have been using a 3 and a 2, then we are saying that our 3 is 1, 1. Our 2 in binary, using the same conversion I showed you, is a 1, 0. So if we AND this, then this one gives us a 0. This one gives us a 1. So 3 and 2 should give us a 2. That is explained, right? Mm-hmm. Yeah. So yes. I don't know. I don't need to prove that because we've proved several, but let me just do it. So we have 3 and a 2. So if we run this, we get a 2. Proven. Good.
Good, good.
Yes, thank you for that. And then now, the next thing we are checking on is bitwise OR, bitwise OR. So the bitwise OR is this, we call it a pipe operator. So this is the OR. It does a bitwise OR. Each bit of the output is a 0 if the corresponding bit of X and of Y is a 0. Otherwise, it's a 1. So that means Again, I'll bring the possibilities in a truth table. So we can have an X, we have an X and we have a Y. And then we have X and then or Y. So there is a possibility of X being a 0, Y being a 0, X being a 0, Y being a 1, X being a 1, Y being a 0, and X being a 1 and Y being a 1. No any other possibility. We've concluded that. So we are saying each bit of the output is just as returns to be a 0 if the corresponding bits of X and Y is a 0. So this is the time we get a 0. Otherwise, it's a 1. So the result here is 1, 1, 1, right? So using that, we want to do a 3 or 2 and see what happens. So our 3 is written like this, and our 2 is written like this. Today you're not calling them 11 and 10. It is 3 and 2, 2 base 2. So this and this, this and this will return a 1. This and this will also return a 1. So when we OR 3 or 2, we get a 3. And proving that, proving that on our Python, we say, let me use this so that I don't go so down. So my OR, where are you? Or I'm looking for
the back slash.
I got it. Yes. So we are expecting a 3 and boom, it is a 3. The next is bitwise XOR operator. Bitwise XOR operator. This is the symbol that we use for the same, this one here. So it does a bitwise exclusive OR. A bitwise exclusive OR. Each bit of the output is the same as, this one is better read when we have already drawn our truth table so that we understand it. So we have X, we have Y, and then we have X or Y. X exclusive or. That's how we read it. So we have 0, 0, those are possibilities. We have 0, X being a 0, Y being a 1, X being a 1, Y being a 0, and X being a 1, Y being a 1. So we are saying now we go reading. A bitwise XOR, each of the bit of the output is the same as the corresponding bit in X, if that bit in Y is a 0. So we are looking for where the bit in Y is a 0. Here the bit is a 0, here the bit is a 0. And we are being told that every time the bit in Y is a 0, the answer is the corresponding bit in X. So if we have Y as a 0, then X exclusive or Y will be the corresponding bit in X, which is a 0. And then here, Y is a 0, so the result should be a 1 because it is that, okay? And then, and it's the complement. A complement, we said, is an inverter, the opposite. Like what complements what? We say a woman complements a man. So it is the opposite. When it is a 0, it is a 1. When it is a 1, it is a 0. It is the complement, what completes something. That's why I said a woman completes a man. So it's the opposite. So when we have y as a 1, then the result here is the opposite of the value in x. So it becomes a 1. It's, yeah, because we are giving it an opposite. And then here, it's a 1. So the opposite of this is a 0. What does this bring out? Every time we have possibility of 0, 0, the x or the exclusive or is a 0. Every time we have a 1, 1, the exclusive or is a 0. Anything else is a 1. From the result we get here. So let's have our 3 x or 2. So our 3 is written as 1, 1. Our 2 is written as 1, 0. So the result here is, what is this? Somebody? 1. Thank you. And this?
0.
0.
So in binary or in bits or in base 2, this is the way we write a 1. So we are saying 3 exclusive or 2 is a 1. So I'm almost done because I was just dealing with this. So it's good I just show my code. So let's go to our collab. Let's have this. Instead of or, then we have an exclusive or, and our result is a 1. It worked quick? Yes. So basically, we've talked about left shift, right shift, and operator. We have talked about or, we have talked about exclusive or, and I would say that where do we apply these? We apply this when we are using in encryptions. We also apply them when we are doing compression. We also apply them when we are using byte manipulation. So that's why most of the time, it is not easy like you find yourself working in base 2. But encryption will want to send you a code so that if I'm sending something to Monica, if I'm sending something to Migot, then nobody else can read that. It is like a security measure so that the other person will understand it. So we use the bits to encrypt the code or to encrypt the whatever you're working on, whatever you work, so that it is as a security measure. We also use bitwise operators for compression and for byte manipulation. So I'll send this, and maybe I'll want you to try this in your own time. Try like doing 5 and true and get the result. 5 or 7, get the result, and try to get the whatever the concept is. Why does the result come out the way you are getting it? Because if you reason it out and get it that right, then you will be good. So blessings and end. Any question before I drop it to Migot?
Lucy, there's a byte converter on internet, right?
If you go online, you look on Google,
Mm-hmm.
you know what to type in there, you should be able to get something like that.
Okay.
Yeah. And then you can also build yours, Sophie.
Oh, okay. Thank you.
Okay, thank you. So try doing this with, I was just using 3 and 2 for our for our class, but if you need a lesson on conversions, binary, base 6, base 16, and whatever, we talk later on the sides. Thank you.
I will also get some notes compiled based on binary, octet, and hexadecimals, their conversion, their addition, subtraction, and all those bitwise. So we'll collaborate with Lucy and then we'll post it on. Okay. Lucy, good job.
Thank you.
Monica, good job. You guys are rocking. By the way, just before I jump in, let me let everybody know, Lucy and Monica were my students last year. They came in with zero knowledge on Python. That was in September. Today we are in April. It's about 6-7 months. They're rocking. So that means anything can be done if you put your heart into it. And then if you show some interest, people will give you opportunity to shine. All right, thank you very much again. And I'm gonna go ahead and talk about the core data types of Python. Now, just before we go in, you've probably been hearing a lot about data. What's data? Okay, let me define what data is. Of course, I got it online. But according to this dictionary, they say data is defined as facts or figures, or information that's stored in or used by a computer. An example of data is information collected for research paper. An example of data is an email. Okay? Data could be your name, your address, your phone number. If I have that data, I gather them all together, and then if I process them, I'll be able to come up with information about you. So facts and figures collected together for reference or analysis. The quantities, the characters or symbols with which operations are performed by a computer. Being stored, you can store them in the cloud, local to your computer, or in a thumb drive in your pocket, or we can transmit it via some radio wave or through your cell phone. Okay, so there's magnetic, optical, mechanical, all those are some of the stuff, including electrical signals, and you can also record them. So things known or assumed as facts, okay, making the basis of reasoning or calculation. So we can get, let's say we want to get data regarding something. That thing we are going to be researching on could be a subject or a population. Population could be population of people or just a subject. We want to get data regarding some facts and figures, maybe regarding COVID. Okay. So Python has what we call core data types. Python's core data type include numbers, that's like 0 to 9, okay? It could include special characters, %, comma, /, colon, and all that. We also have strings. Strings are like A to Z, 0 to 1, 0 to 9, and in combination with all those other special characters, we have strings. And then we have what we call lists. We have dictionaries, we have tuples, we have files, and then of course we have sets, types, none, and Boolean. So I'm gonna go ahead and maybe share my screen, which I probably was not doing that.
Yeah.
Okay, sorry about that. Now, in Python and in most programming languages, we divide, or we tend to talk about data structure. That's a big wing in computer science. Data structures and algorithms, but this is going to be just data structures. So we divide data into two, data structures into two. We have the primitive types and then we have the non-primitive types. So when we talk of strings and numbers, and of course I would take Boolean or the Boolean numbers or the true or the false, the 1 or the 0, we combine those together with numbers and strings. We call those primitive. Primitive in the sense that they've been existing ever since, as much as even before the computer was there. Okay. And then we have the non-primitive data types. Now we have the lists, we have the dictionaries, we have the tuples. Some people call them tuplet, depending on where you come from. And then we also have the files, we have the sets, we have the types, and we have the none, okay? So I'll go ahead and break it down. So don't even worry about anything. We just break it down for you. Now the numbers, we have like the 0 to 9 numbers, and that's a data type. Okay? These are the most important. The usual object sets, we may include integers, the floats, the fractions. Okay, of course, the fractions, if we break it down, simplify, we get the floats. And then we also, of course, have the floating point number. Okay. And we also talk of like unlimited precision, long integers. Say, for example, we want to declare a variable. And the variable will be talking of like billions of, let's say, billions of dollars, or a billion as in the population of the continent. If we were to declare that in a variable, then we know we are going to deal with a very long number. So we have to say it's a long. Of course, population can never be percentage, can never be a fraction or a float. We are going to say, hey, there are 7 billion people in the world, or there are 2 billion, or there are 2 billion in India, maybe there are 3 billion in South America and all that. So we have to declare long numbers or long integers. And then the complex numbers, which Monica also talked about, those normally at this stage, we will not touch or will not talk a lot about them, but we'll just basically touch them for you to be able to know there's some stuff out there known as complex numbers. When we talk of complex numbers, we tend to gravitate towards science and engineering and also mathematics. So these are basically imaginary numbers or imaginary parts. We also have the fixed and the precision decimals, and also we have sets. Python's basic number types support the normal mathematical operators, which Lucy talked about. For instance, the plus sign, that performs addition. And then we have the star, which performs multiplication. We have the 2 stars, which is an exponential or e raised to the power of. Okay, as you can see the example here, we can add those 2 numbers. If we add those 2 integers, we get an integer. If we multiply that float with that number, we basically get what we call the floating point multiplication. And then we can raise 2 to the power 100, and then we get the equivalent of that out there. Other data types in Python include more exotic number objects, such as complex numbers, which I told you, as much as you don't want to worry about them, at one time you will, but now don't worry about it. Those are for mathematics. When you go really deep into Python, you'll be using for mathematics, for science and engineering. We also have the fixed precision decimal numbers and sets, and the third-party open source extension domain as even more matrices. Like we have the NumPy. For advanced class, they're probably already talking about this NumPy, the number Python, or the numbers in Python. Then the long data types in Python, or the long integer, like if you were to declare billions of dollars or billions of people, you're going to go a little bit of a stretch. So you have to reserve a large memory space so that you can be able to accommodate that value. Okay, we can get an integer, unlimited size, written like integers and followed by uppercase or lowercase l. These long data types in Python exist only in Python 2.x integer. That means 2.7, for example. Okay, so there must have been an improvement. So we'll see here in a minute. So they are long, they're up to 32-bit integer. That means the number has to be up to 32 characters. Automatically, the Python will take it as a long. However, you can explicitly, you as a programmer, you explicitly, okay, can create one by adding an L after the number. Okay. Explicitly means if you have to involve a decision, then yes. Implicitly means the system, the program, I mean the computer or the interpreter will already have it decided for you. Now the complex data types, also known as complex numbers, are of the form like that, bj, where A plus bj is A and B are floats, and j or small j represent the square root of I of -1, which is actually an imaginary number. The real part of the number, is there any question? Okay, the real part of the number is an imaginary as in part B. Complex numbers are much more used in Python programming, especially like I said, in engineering and mathematics. So at this time, maybe until you hit the higher level of Python programming, you will again encounter them. But I'm not saying that they are not important to talk about, but they are good to know that they exist. Okay. Another data type, we have the strings. One of the core data types in Python are used to record textual information. Your name, my name, your address, your phone number, all will make a string. Okay. Strings are also an example of what we call sequence in Python. That is positional ordered collection of alphanumeric characters. Okay. Sequences in Python basically maintain a left to right, like the way we normally write, but it depends on where you live. Some, I think in the Arab countries, they write from right to left. So that, but still a string. Okay. So we have the sequence operation. Strings, quite like the sequences, support operations that assume a position order. So, and we'll see this when we go deep into lists and we go into tuples and also dictionaries. For example, if you have a 4-character string, okay, you can verify its length with the built-in length function, which is len, and fetch its component with the index. So here, okay, this is SPAM. And then we can list. This will give us, we save everything into S. So this is a memory location S. And then we use length as a function to find the length of the word span. And we know this will be 4 characters long, so we get it. So the first item in S, indexed by 0, this will always be starting from 0. And then 1, and then 2, and then 3. Continuous like that. If you say you want to get the second position of index, I mean the first position of index number 1, it will always be P here. If it's for 0, it's going to be for S. Okay, and you see a lot of that when you start talking about tuples, also lists. Now, every string operation is actually a sequence of operation. Okay? That is, we operate or work on other sequences in Python as well, including lists, tuples. In addition to generic sequence operation, though, strings have operations all of their own, available as methods, functions, which are attached to objects, which are triggered with a call expression. So we'll talk about that. And for those people who have already read ahead, you've probably already seen some of this in the notes. Now, Python allows strings to be enclosed in either single or double quote. You can use either or. Remember, like Monica said, if you are to, let's say, write the word, I don't want that, and you put it in a single quote string, and then you say the word don't, you put apostrophe, you probably want to escape that apostrophe in the word don't. Otherwise, you want to use double quotes, and then you don't have to worry about escaping that. So whether you use single or double quote, doesn't matter, but you have to be very aware of that particular apostrophe in case it exists in there. Okay. So we have the lists. Okay. Python list is the most generic. Okay. If you had already done any other programming language, lists are almost behaving in Python just like they would behave in arrays in other languages. And that does not mean that Python does not have arrays. Python has an array, but they're not built in Python. You have to import it. You have to get it from, it's a library, you have to bring it in. But lists are built in. So lists are positional ordered collection of arbitrary typed objects and can be of any length. We can make it big. We can put your name, your phone number, your address, your date of birth all in one list, and then we use it to basically manipulate. Now, lists like strings are also mutable. Mutable means it's writable. You can write to it. You can edit it dynamically in the program. Dynamically means when the program is running, you can add things to it. Okay? It's mutable. You can actually add or remove. You can append or delete in lists. Okay? And you'll find out pretty soon here that that's not the case with tuples. So lists like strings are mutable. That means it can be modified in place by assigning to offset as well as variety of lists method. Typical example of mutual data type in Python. Okay? It can contain mixed data types. You can mix oranges, bananas, pineapples all in one basket in a list. But you can't do that if you are dealing with arrays. When you do arrays, it has to be one bag has to be for just pineapple, another bag for just oranges, another bag for just lemons. But in lists don't care. Okay? It can be mixed. Now lists are they generally support all the sequence operation for strings. So the only difference that the result is usually list instead of strings. When we put it in, we can bring it out, it's always going to be a list. It's a list. It's not going to be a string. But if you save, let's say, your name into a string and you put that name as first name, it's going to be a string. It's not going to be a list, unless you specifically state so. Okay. So if this was a list, it's going to behave more or less the same way we would do with a string. Okay. So here we can save the word span into S, okay, and then we basically get the length, and then we get the length as number 4, which is 4 characters. Okay. We do that. The first index position for the S in the word span is going to be at position 0, it's index 0. It's index 0, but it's actually position 1. Just make sure you understand the difference between index and position, because it will soon come to haunt you if you don't get it right. Index will always start from 0, but it's actually at position 1. So here we have index 1, which is actually the P, but it's at position 2. Okay. Nesting, this is perhaps the best feature of lists. You can list items, you can put your full name, your address, your email, your phone number. Then you can add additional other items to the same list. One of Python's core data types will support arbitrary nesting. Nesting means you can put one inside another, inside another, inside another, almost to the point of whereby it can be very confusing, but at least we'll be able to actually track it. Now they can be nested in any combination and as deeply as you want it. For example, you can have a list containing a dictionary, which leads to another list, another list, another list, another list. So multidimensional arrays in Python are a classic application of this kind of feature. Okay. So remember, I did not even say arrays, because arrays, we don't count it among the core data types of Python. So after talking about lists, now we have Python, we have our dictionaries. Now, what's the difference between Python? We've already talked about list. Now, list, when you declare it, it has to be declared in square brackets. And remember, lists are mutable. You can actually edit it on the fly, dynamically. Dictionaries, the difference you'll see here shortly. Okay. Python dictionaries are known as mappings. Okay. Mappings may also be described as collections of other objects. You can put like your name, your phone number, your address. But the difference here is Python dictionary will always be name and value pair. Name and value pair, they don't have to come in any order, but there's always the name and then the value, which means if I put a name as a variable, then say the word Judith will follow it. I can say first name, Judith. Last name, you can say Mwangi. Okay? And then you say phone number, say that phone number. Address that way. So that kind of structure has to be like that. But for the dictionary, it will have to be having the quiggly brackets. I don't know if that's clear to everybody. That kind of bracket whereby you everybody call it differently, but if you look on your keyboard, it's going to be the one which I don't, let me see if I can draw it here for you. Anyway, I'll show you here on the screen shortly. So mapping may also be described as collections of other objects. They can store objects by key instead of by relative position. So we have somebody's name, let's say name, and then we put that, then we put Judith, okay? Okay, let me go ahead and say that. Maybe small one, small like this. So this is first name, and then we decide we have to have a second name. So we say this is first name, so we have second last name. First name. So last name here will be Mwangi. So if you see anything like this, and then we basically go ahead and use that in Python, that means this will be a dictionary. If you do the same, if you were to do the same thing like here, let's say names. The names, and then we say names, maybe addresses, maybe phone numbers. And then we enclose with that, then something like that will fall under the category of lists. This will be lists, and this will be dictionaries. So just for the sake of this one right now, all this will be in your notes anyway. So we call it mappings, which means that we have to have a key value pair. So this one here is going to be the key, and that's the value to that key. And this is the key, and this is the value to this key. But as opposed to lists, okay? Lists, this will probably be a name, comma, address, comma, phone number, maybe comma, email, all the way until the end. So the distinction here is the square bracket. And this one, the distinction here is the, I call it, some people call it different, but I'll call it squiggly bracket. Okay? Remember, this one is mutable. That means we can change it on the fly. And this one is also mutable. Okay? So mapping do not maintain any reliable left to right order. So dictionary, they don't have to have any order. They simply map keys to associate values. Dictionaries, the only mapping type in Python's core object set are also mutable. That means we can change them. These data types may be changed in place on the fly dynamically and can grow or shrink accordingly. Okay? Now, when written, as literal dictionaries are coded in curly. Curly, that's the right word. Curly brackets or braces, and consist of a series of key value pairs. Okay? Dictionaries are always, anytime we need to associate a set of values with keys to describe the properties of something. Okay? Now let me remind you one more time. This is very special. You need to understand this to be able to actually even understand what and where we are going. Because this, we just talked about the primitive data types, dictionary lists, and of course, we're going to talk about files and tuples. Those are going to be the non-primitive. But these non-primitive data types cannot or will not or will never exist without the primitive data types. The primitive data types are the ones which actually help the dictionary, the lists, the sets, the tuples, and even the files to be built up. It's almost like we can say the primitive are the bricks which help build the building. And the building are now the complex data types we're talking about. Okay? The dictionary, the tuples, the sets, in the list. Okay? So as an example here, okay, consider the following. Now we have food. Okay? We can say that food is actually some food known as spam. If you've been to Hawaii, they're probably very common down there. And then quantity, 4. Color is pink. So this is a dictionary describing everything with a key. So we have the food, yes. What type? Spam. We have how many? Quantity, how many? 4. Color, how many? What type of color? Pink. So we have the value key, key value pair for the dictionary. Now remember the dictionary and also remember the list, they're both mutable. And when we have to declare them, one uses that kind of brace, which is curly braces, and one uses square. So this one here is square brackets. Square brackets or square braces. And the other one will be this one right here. Okay. These are very special. If you understand this, the stuff ahead of you will not be any bigger than it. It's going to be hitting home just like that because you'll be using a lot of this to build your very complex programs. Now, tuples. Tuples different. Now, if we had something like this, okay, something like that, and then we come here and then we say we want to declare that as a tuple. The only difference is going to be now, instead of that, we'll have the regular brackets, which we call parentheses. Okay? So tuple is an immutable. You cannot change the tuple. If you try to change it on the fly, it will give you an error. You cannot add or remove from it. It will always be the same. So tuple is an immutable sequence Python data type. The tuple may contain mixed data types. You can say oranges, apples, and bananas. You know, just like lists, we can do the same. Just like dictionaries, we can also do the same. We can mix them. Tuples are created using round brackets or the parentheses. Here we have a tuple consisting of 3 different types of fruits. Okay. Now we have the apple, the oranges, and the bananas. And then we can print it. It's going to print the whole of those. The tuple object may be grossly explained as a list that cannot be changed. Once locked, it's locked in, and then we throw the key. That does not mean that you as a programmer you cannot change. You can change it manually. But when it's already in the hands of Python interpreter, Python cannot change it. It's already locked in Python. Say, for example, you have somebody's address, somebody's, let's say, One thing you'll never change unless it's very special circumstances. For example, here in the US, my social security number is going to be the same. Unless I go into some kind of witness protection program, then they might change it. But so long as it's not changed, we can keep it in TAPL. My name will probably not change. It's going to be the same. But the moment I decide to change it, then it can be changed. But most of the time, it's going to be the same. Your account number, your bank account number, for example, it's going to be, those are some of the things you want to put in your TAPL. So the TAPL object may be grossly explained as a list and cannot be changed. Tuples are in fact sequences like lists, but they are also immutable. Immutable, it cannot be changed, like strings. Okay? Syntactically, tuples as code data type are coded in parentheses. Those are the regular brackets instead of square brackets or the quadric or the curly braces. Okay? So that's bringing us to this one here. If you can declare this a tuple, 1, 2, 3, 4, and then we go ahead and print the tuple. It's going to print the length of the tuple from, this is the position 1, 2, 3, 4. You can say tuple, and then we try to concat. If you try to add a new thing to the tuple, let's say we have up to 4 already in T, and then now you want to add 5, 6. You try that. Tuple will not do that. Tuple will cause problems. You cannot concat it. It's going to be immutable. Okay? So that's good for tuple. So I'm going to let you sync, let it sync for like about a few seconds. It's going to be important. This is a good time if you want to ask, you can ask, so we can real quick jump into it. Because I know it's coming at a very fast rate for you. Any question? Okay. I'm taking that as a good, people are really good to go. So files, okay? Before we go into files, let me go ahead and introduce some diagram here so you can see the data types. So here we talk of the data structure, the primitive and the non-primitive. Remember we talked of the numbers. The numbers, of course, we talk of the integer, the float, okay? And then we talk of the string, and then we talk of the boolean. These ones here are primitive. These are the basic building blocks which actually help us build the non-primitive data type. The non-primitive data type, I talked of the arrays. The arrays exist in Python, but not, I would say not naturally. They don't come. We have to import them. Okay, when you go into advanced Python, you'll be learning the NumPy. NumPy is a typical array, but we import it as a library. You can also import array as an array, but it does not have all the power of NumPy, but it's still an array anyway. But remember, array will always only take homogeneous characters or elements. And homogeneous in the sense that if it's oranges, it only takes oranges. It's pineapple, only pineapple. You cannot mix anything. It's people, just people in there. You cannot mix with animals. Okay? Unlike lists or tuples or dictionaries, arrays don't mix. Array is homogeneous, but these other ones like list, tuple, and dictionary, they'll be mixed bag of items. Okay? So we have here the list, the tuple, the dictionary, and of course we'll talk about the file and the set. And then we go down. Now this is not what we are going to talk about in an introduction. We will not have time to talk about it. But I talk about it in data structures, okay? And I actually basically talk about it in advanced Python, but on the fly. So when we talk of a list, we have two types. We have the linear and the nonlinear. The linear is like the following line, okay? For those people who, let's say you deal with a lot of, let's say you go out and eat, you go to the buffet, or normally like you have some kind of stack, right? The plates are stacked one after the other up to the top. So when you come to pick on a plate to go and use for, let's say, getting your food, you will not go to the one in the bottom. Of course you can, but it's not gonna look funny, especially in a crowded environment. So you wanna take the one up at the top. So you take the plate up at the top and then you go serve yourself. That's a stack. So in the stack, the last plate which was put in there is the first one out, which we're going to take out first. So last in, first out. Okay, that's a stack. Now, if you go to, let's say, voting, you go to the bank, or you go to the post office, you line up. That's a queue, right? So the first in is the first out. That means the first come, first served. If somebody, of course, in Kenya, can happen. People sometimes come behind you and then they want to be at the top of the line based on who they know. But in conventional wisdom, that is not really what happens. So the queues is first in, first out. The stacks is last in, first out. Remember, LIFO, okay? Last in, first out. The other one is first in, first out, okay? Those are the lines. Then the linear, okay? The word linear for line. And then we have the nonlinear. The graph, we have cases whereby we deal a lot with lately, social media, okay? I could be a friend of one of you, who might be a friend of three of you, and just because of me knowing this person, I'll basically be able to access the other three. And that's graph. Or we can actually draw the nodes, like I'm in Dallas, some people in Nairobi, some people might be in Kampala, somebody might be less in Seattle, Washington, somebody might be in Hawaii. Those individual cities or continents, those are nodes, and they're all connected, and that's going to be falling under the graphs. At time we'll try to talk about that a little bit, just a little bit. And then we have the trees. The trees, the way we organize, like if you have your Windows or even Mac, even Linux, you always get your files saved in a particular folder. Most of the time they go into document folder. In that folder, there are other folders you can create. So they have a hierarchy of items. You know, folder, another folder, subfolder with different files until the last one. Or in a company, you have the president, the CEO, maybe the chief executive or the accountant. All those are hierarchies. And that's exactly falling under the tree, how the trees are getting organized. Okay. So after bringing that, now let's go ahead and talk about the files. Now that we know where the file falls in, it's under the non-primitive. Now remember, files, if I create a record, my name, my phone number, my address, my email, okay, and all my particulars will be under my record. A group of records collected together will form what we call a file. Okay. Now, a file is a collection of records. Now, we call file objects may be described as Python's code main interface to external files on your computer. They are one of the popular core data types in Python, but without any specific literal syntax for creating them. Okay? To create a file object, one needs to call the built-in function. So we'll also talk about that really shortly here. The built-in function, we call it open. You cannot write or read from a file until you open it first. Okay, so to create a file object, one needs to call the built-in open function, this one right here. In Python, when you see a word followed by a bracket and then close the bracket, that means it's going to be a function. Very important, you have to know that. And sometimes you have a function, you can pass parameters into that function. Some of them we don't have to. Depends on what we want out of it. Okay, so passing in an external file as a string, let's say in here, we come and declare a file here. We call this function open, and then we pass the name file data.txt. This could be any file. It could be a log file. It could be a security file. It could be a file which for you, maybe you as a security analyst, you're going to use, just determine what's going on. So you have to read it first. So when you read file, you pass it as a mode. What's the mode? Reading for R, but this one is for writing for W. So we basically say we pass an external file as a string and process the mode string. For example, to create an output file, you pass in its name, which is here, okay? And then W, you process the mode to write to that particular file, which means we can bring this file and then we write onto it. When we write onto it, we basically append below that particular file without overwriting the contents. You can do that. In this case, if that file is containing some items in it, the W will basically overwrite everything. So you have to be very careful when you deal with files, but that's something which you'll be able. This is just a tip of what we are going to learn as in this one, but we'll go into detail about the files. So we can say, write the word hello and then then enter key. Okay, and then once you do that, then you close it. Every time you do that, you want to close the file so you reserve any other resource you can be. It probably might be wasted. Okay. The other file objects support additional features, offering more ways of reading and writing. So when we talk of the R+, it's going to be reading and writing, which means you can append to it and read from it, append to it and read from it. So we have the read line, which reads one line at a time, and so on, as well as other tools which we will also be able to talk about. So that being said, okay, I'm gonna go ahead and opening up again for questioning, if you have any question, before I go to what I'll call the precedence and associativity. Okay. That will be more of the math side of it, but not really very detailed, but just to let you know what's gonna be expected in this class. Any question? One, maybe 1 second, 2 seconds. Before we go to anything else?
I have a question about this file. So you're trying to open when you write the lines of code to open a file, as in instead of manually opening a file on your Windows, this is the code will open a file. Is that what you're saying?
Yeah. So when you pass in the function, that's a built-in function in Python, right? The open.
Mm-hmm.
You have to pass 2 parameters, okay? Or sometimes we call them arguments. So when we say open, you open what? This one will always be the file name and its extension.
So I can say like F is equal to open, like employees.txt. I can, okay.
Yeah, employees, but you always have to specify here. What are you opening it for? Is it for reading, for writing, or for both?
Okay, got you.
Yeah.
So W stands for you're opening it for reading and writing, or just writing?
W is for writing.
Okay.
R for reading.
Okay.
And then this R+, which will be for appending or reading,
okay.
Yeah, writing and reading. And then we have an A for appending. We just append to it the file. Okay, is that clear?
Yes.
Cool. Any other question? Anybody else?
Yeah. Is it possible to combine the W with the R at the same time, or you have to specify one condition at a time?
Why would you want to combine both if you have R?
Like you said, writing, W for writing, right?
Okay.
Like
R for writing. I mean, I'm sorry, R for reading, and then W for writing form, right? But remember, Alex, if you do, let's say you do the data.txt, you want to write to it, you only want to do one operation, right?
Yes.
you want to read from it, you want to do just one operation. And then there's one for R plus, which will allow you to do both. If you want to read from or read to. And then you also have the A for append, which you can append to. Append will always just bring on top, will be like a bunch of stuff, and then you just add on to the top, into the bottom.
Okay. Thank you. We don't have execute, right? We don't have an option to execute the file. It's just read and write.
Basically, you read and write. Why would you want to execute? It's already open. The function open is executing.
Oh, I see. I see. Okay.
The function open is to open that file, and then you pass the options for what. Now remember, this might not be executing any other file other than like the ones you can read. You probably don't want to pass like .exe. Probably it's not going to work. Those are system files. This can only
that makes sense.
CSV file, Excel spreadsheet, or a data file or a log file. But I can guarantee you that you get to see a lot of this because it's going to come up in some of the notes we are going to soon. We are going to pretty soon talk about. Let me see if I can tell you real quick here. Okay, in your syllabus, files will come. Let's see here. I don't know if I can tell you, but the next section, it's going to come the last section, the first one for under file processing and pickling. That will be a big deal. So you'll be able to see exactly what modes you can use for writing or reading from a file. It's going to be a big deal. And you'll be able, hey, this is my thing, man. Always want to try this program. So don't just read and say, hey, I got it. If you try, you get an error, it will help you more to understand and to be able, it's going to be like opening some neurons in your head. So next time you know exactly, oh, the last time I got this error, now this time I need to be very careful. So you want to always type and test them. It's going to work for you. Okay, any other question? Okay. Assuming that there's no question, but feel free to jump in. I don't mind. Now we are going to talk of the precedence and the associativity. Now, I'm assuming most of us from Africa, you probably know just the bottoms. The brackets of division, multiplication, addition, and subtraction. Now, it's very important that we understand the precedence, because if you're doing your calculation, you really want to get the accuracy. If you get it wrong, and then you send that probe to Mars, it might cost billions of dollars. It might not come back. Or you might not do the operation it's meant for. So it's very important that your math is accurate. How do we get this accuracy going? So we always want to make sure that the procedure or the processes has to be in particular sequence. First of all, the first and foremost, if you're given, let's say, a piece of math to do, if it's a long one, you probably want to subdivide it. Subdivision in this case could be like, hey, I want to make it such that I know the first parts first to deal with. So in here, the following table will list all operands. All operators, what Lucy talked about, from the highest to the lowest. And let me warn you, don't have to cram this. You don't have to know it off your head. This will always be available for you. If you're a programmer, feel free to reference. Nobody will ask you this, probably in a test, but if they do, probably you have an idea. Exponential means the 2 multiplication, then with that, we raise it to the power. So if you say 3 exponent 2, that means 3 raised to power 2. So in the precedence, like what comes first will always be exponent. We raise it to the power of. And then we have the complement, the unary plus and the minus. Now the complement, the unary plus and the minus. These methods for the last two are at plus, at, and the minus at. So you just have to know this. They come immediately. If you're given a range of numbers, you have to, if you have to put some in bracket, then you want to see what you can group them to. And then we have the multiplication. We have this, just the normal division. The normal division always is there existing. We have the modular, which always will only give you the remainder. If you say 10 modular 3, you'll get 1. Okay? If you say 10 divide by 3, then you get 3. And then there's always that floor division. Floor division will give you the lowest. If you try, let's say, 10 divided by 3, if you really want to know, it will give you 3 on the floor division. And then we have the typical addition and the subtraction. This one come like number 4. And then we have the right and the left bitwise shifts. Okay, this will come number 5. Okay, and then we have the bitwise and. Okay, and then we have the bitwise exclusive OR and the regular OR. The exclusive and the regular, those are two different ones. If I call, let's say I call Sophie, and then I call Alex, can you both come here? I say, Sophie and Alex, come here. Both of you come, then that condition is met. But if I say Sophie or Alex, then or, if all of you, if either or, it means either Sophie or Alex come, then that condition is met. But in the exclusive or, that's going to be totally opposite of what we expect to happen. Okay. So I'll have, one thing I realized we really need, we really put a lot of notes here, and then I will share with you so that you can get the understanding. Some of them will not be like immediately, but it's good to understand the basics. You know, if maybe one day you go into security and encryption, you need this. Or if you want to decipher something, you need that. Okay. Then we have the comparison. Of course, I know 2 is less than 10. 10 is not equals to 2. 10 is greater than 2. Okay, those are comparison operators. And then we have the 2 equal sign. We say that's a comparison. So we can say, okay, instead of greater than or equals to, we can use the equal equal. That means equal equal means if 10 equal 2, that's not true. But 10 can be equal 10. Okay. So we use a lot of that here in terms of comparison. We use less than equal sign, sorry, less than or greater than. And then we can, instead of this one, the plus sign here, the 2 equal sign here, we can reverse that or negate it by using the not. We can negate it using the not. Okay, that means 2 is not equals to 10. So that's exactly what this means. 2 is not equals to 10. And then we have the assignment. We can assign, let's say, whatever Monica showed you, we can assign 10,000 to salary. And then we use it for calculation. But sometimes you probably want to make sure that before you use it for calculation, you do the integer conversion or the float conversion so that it's explicitly known to the memory that this is an integer or a float. Now remember, is not. We have the is and then we have the is not. The is means it's actually yes. The is not, no, it's not. So if you remember what Monica showed you in there, that's going to be in there. Those are what we call, they're falling under, excuse me, they're falling under what we call the associativity and also the precedence. Okay, so we come here and then we can say not, and. The not here is going to be negating, just like here. Is it in? Hey, Can you go into that room and see if Monica is in there? And then you come and say, no, she's not. Okay. So it's either or. Monica is in the room, yes. And then you come back and say, yes, Monica is in the room. Monica in the room, you say, no, Monica is not in the room. Or Monica is in the room. So you can say is in, that means she's a member of that, she's actually in there. Okay, and then this one and that one, they work together. So those ones are some of the things you need, but this really come way below in what I call the table or the hierarchy. You can use this up at the top, but if you really prefer this one, that's fine too, but you can always use the equal sign, the not sign, and all. So in Python programming language, an operator is a special symbol that is used to carry out specific operation on its operand. Remember what Lucy said, operand. We have the operation, the plus sign, the operand, the 3, and the 2. In Python, we have a rich set of built-in operators to help carry out different types of operations. There are 2 operators for assignment, arithmetic operations, logical operations, and comparison operations. Arithmetic, you can say plus, minus, division, and multiplication. The logic operators less than, greater than, or the equal for comparison. Okay. Among others, okay, so Python operators can be used with many types of variables. It should be a variable here. Or constants, but some of the operators are binary. Binary, remember, is either 1 or a 0. Binary numbers, meaning they take 2 operands, but a few are unary numbers and only take 1 operand. If it's a not, it's either switch on or switch off. It's either 1 or a 0. Okay, it's either true or false. Okay, so Python divides the operators in the following groups. Okay, we have the arithmetic, we have the assignment, we have the comparison, we have the logical, we have the identity, we have the membership, and we have the bitwise operators. Okay, so the operator precedence affects how an expression is evaluated. If you get it wrong and you work at NASA, you know you lose billions. You don't want to put your job on a scale. Am I going to be fired or not? So be sure before you execute that thing, be sure you're doing the right thing. You don't want to get dimensions in Canada and then you forgot to do the conversion in Canada. They use centimeters just like they would do in Kenya, and I believe in Uganda too. And then these are Commonwealth countries. And then when it comes to the States, it has been in inches. So I have to find out 12 inches is equivalent to 30 centimeters, and I have to do the precision math. So if you get it wrong, you can easily get it wrong if you don't do the precedence right. For example, x equals to 7 plus 3 times 2. Here, x is assigned 13, not 20, because we know what comes first. You have to multiply this times that first, 6, and then you add 7. But if you just want to approach it from the left to right, then you start, you basically take 7, you add to 3, get 10, and then you multiply by 2, get 20. And then you come out of the exam room, you're very happy, you got it, man, I'm going to get this, you know, before you knew it, it's wrong. So you got to be very sure that the operator X come before the operator plus sign, always. Okay, so that you get it right. The operator with the highest precedence appears, okay, at the top of the table. If you look here, multiplication will come first, right there. You see, plus come way up there, 5th. So if you get higher, then you do a lot of math with your Python, you probably want to get this kind of printout. So you know what you're doing most of the time. Don't cause anybody any trouble, any money. Okay? Imagine you're doing a payroll and you get that wrong. Somebody may be paying might be paying somebody extra. And then they realize that after 2 years, each time they were paying this guy, they were paying this guy 20, maybe 30 shillings extra or dollars. That's going to be a problem, and your program might be at stake, or even your job. So the operators with the highest precedence appears at the top of the table. Those with the lowest will always appear at the bottom. When more than one operator appears in an expression, the order of the precedent depends on the rules of precedence. Say if you have more than one, then you take the rule of the precedence. Python will follow the same precedence rule for its mathematical operators than mathematics does. So sometimes you want to leave math alone. Make sure you go by what Python wants. Parentheses have the highest. The bracket will always have the highest and can be used to force an expression to evaluate in the order you want. Bracket of division. If you went to school here in America, for example, you went to, let's say, college or high school, then they call it something else, not borders. And that's something else somebody will probably tell me, I don't remember, but it's something with PEMDAS, right? So parentheses have the highest precedence and can be used to force an expression to evaluate in the order you want. Since expressions in parentheses are evaluated first, okay, so here we'll be, first of all, we'll be doing what is in the bracket first. So we get 2, right? And then we get 2 times 2, which is going to be 4. If you come here, we first do whatever is in the bracket first, we get 2. And then we say 2, 2. I mean, this is going to be 2. And then we say raised to the power of whatever is going to be here, this is going to be 3. So 2 raised to power 3, we have to have 8. You can also use parentheses to make an expression easier to read. What personally I call subdividing it. So you conquer and then you roll it, okay? So you must subdivide it. So if you were to multiply, let's say, 100 by a minute and then divide by 60, in this case, the parentheses don't change the result, but they reinforce that the expression in parentheses will be evaluated first. Exponential has the next highest precedence next to the brackets. So if you are to have this one, that means we raise 2 to the power of 1. It's going to be 2. And then we add 1. That's going to be 3. Okay. You have to follow that order. This will come first. But if your bracket were first, then you go with the bracket first. And this should not be 4. If you come out celebrating, then you probably want to think twice. You probably lost billions of dollars in that probe to the moon. And then that might cost you a job and you'll appear on TV and everywhere. Be careful. So if this was fast, then we have to raise 1 to power 3, come with 3, and then we multiply with 3, then we get 3. So don't do this other way, 3 times 1 and then raise to power 3. That's going to be something else like 27. So this is very self-explanatory. Multiplication and both division operators have the same precedence. Multiplication and division, no problem. You know those ones, you have them in the same box. Which is higher than addition and subtraction. Okay, multiplication and division will be higher than addition and subtraction. But up at the top of multiplication and division, we'll have the exponents. Up at the top of the exponent, we'll have the brackets. Okay, so these are higher, which also have the same precedence. Okay, so same precedence as in addition and subtraction. So if we were here, we multiply this one first, and then we subtract. So that's going to be 5 rather than 4. If we're here, we have to multiply this one first, which is 4, and then we subtract from 5, which is going to be 1. This should not be 6. Mark this one, so this one will appear in your next quiz. Operators with the same precedence are evaluated from left. If you have a division and multiplication, or you have a subtraction and addition, then we go with the first one on the left to the right. Okay. In algebra, we say they are left associative. Mark that. Ladies and gentlemen, mark that. So in the expression, 6 minus 3 plus 2, we basically get 1. We start from 6, subtract 3 from it, we get 3. 3, we add to that, it's going to be 5. Okay? The subtraction happens first, which is going to be 3. And then we add 2, 3, which is 5. That yields, is that true? This one is 3 plus 5. 3 plus 2, that should be 5. It's not 3. I must have been rushing there. Okay, we then add 2 to the result. So this is 3. We add 2 to the result, therefore that's going to be 5. Okay, we got it right. Okay. I hope nobody's sleeping now. We're almost done. If the operators or operations have been evaluated from left to right, from right to left, the result would have been 6 minus this one. This one has to be in the bracket, which means it's 5. Therefore, 6 minus 5 is going to be 1. Due to some historical quirks, okay, some mess up, an exception to the left to right left associative rule is the exponential operator. This one has no way. It has to come. A useful hint is to always use parentheses to force exactly the order you want when exponentiation is involved. So if you were to do this, we have to put them in bracket. So the rightmost operator goes first here. If you were to do this, the rightmost will go first. This one will give us 9. Then this one, the power of 9 will give us something, which is 522. And then this one, and this one, use the parentheses to force the order. So you have to come into the parentheses first. 2 raised to power 3. It's going to give us 8 raised to power 2, which is 64. So make sure you master this. This is very important, and that's in Python. If you were to go to any other language, I cannot address that, but this is Python. Okay, of course, any other language will address it differently. Okay, now that comes to the end of what we call the precedence and associativity. We also talked about the numeric types, the core data types. We talked about the bitwise operators, the basic operators, the variable names, and also basic programming in Python. I'm going to open it to questions. I know you guys are tired, and I really appreciate your time, and thank you very much for coming and listening. So I'll open for you to answer, to ask questions. Please, feel free. Thank you.
A question on the equality. I think you mentioned something about equality operators. It was equal. Mm-hmm. Is it the same as the one we use on if function? And what's the difference between if you say if is equal to, or maybe something, and then if is equal something else? What's the difference?
That's Alex, right?
Yes.
Okay, say one more time. I'm sorry. Say if, we have to say
yeah.
If Alex, let's say if Alex is not equal to George, right?
Exactly. And then what is the difference if you say if Alex is equal to George? Just one. Is it?
Oh, no, that's not going to work.
That's wrong.
Syntax error, because that's an assignment. Normally, you want to assign, let's say here, look, you say name. Let's say name is Alex, right? That's assignment, okay? And then I say name 2. I say name 2 equals to George, right? You see that? And then I can say if, let's say name 1 equals name 2, then we say, is it true or false on name 2? And of course, we know it's not true. It can only be true if this, I'm sorry, this is going to be true. I'm sorry, this is going to be, okay, hold on one second. This name 1, Okay, we start name 1, name 2, right? But if this was name 2, I'm sorry, if this name 1 was George and name 2 was George, then this will be equal. This will be true.
Okay.
If that means name 1 memory address will contain the word Alex. Name 2 memory address will contain the word George. And then you come in here and then you say, if name 1 memory location equals name 2 memory location, this will be false. It can only be true if both contain the same name, either George or Alex, but not a mix of both.
Okay.
I think we can.
And
Go ahead.
I was gonna say, if we can say that if name 1 is not name 2, then we say true, else false.
Yeah, that will twist things around, right? Yeah, so you know name 1 is not actually it's not equals name 2. And then we say name 2 is George. Then if you come here, this will be true. If we were comparing the two. Of course, this was false, right?
Right.
Now it's gonna be true. Because we say name 1 does not actually contain Alex. But we are going to compare name 1 to name 2, which contains George. Then we'll have to come up with something. It's kind of like negating it. Okay? If we say Sophie is in Atlanta, right? And then you say another Sophie in Georgia. But we say, no, Sophie in Atlanta is not the same as Sophie in Georgia. Is that right? Then we have to go and say, maybe, maybe not. But in this case, it's going to be, do they have the same address in the memory? Okay, if they have the same address, then we know Sophie in Georgia is the same one who is also in Atlanta, because Atlanta is in Georgia, right?
Right.
Yeah.
And George, if you allow me.
Yes.
I don't know who asked the question, but I also want to just give him a practical way of looking at the difference between these two. I hope you're able to see what I'm writing on the screen.
Okay.
So what this does, like Georgia said, and also Monica said, this assigns something to the memory. So for example, let's have N for name, and then we say N equals, and then we say George. So I'll use G because I'm writing. So we say N equals George. So what this does is to tell our CPU to create a variable or a temporary memory location that is called N, then take G and put inside it. So it's like it assigns letter G to a memory location called N. But when we use the double equal sign, then we are talking about a relational operator or a comparison operator, like Monica explained. So now, if we say N, and I'll still just use the same, N equals with double equal signs G, then what this means is there is a memory location that is being called N. And there is also another memory location being called G. So what this does is, it's like telling the CPU, go to the memory location called N, check what is inside it, then go to the memory location called G, check what is inside it, compare them, and give us the result true if they are the same, and the result false if they are not the same. So supposing N had a 5 and G had a 5, then the result will be true. Supposing N had a 3 and G has a 5, then the result is false. Thank you.
Very good.
Thank you. Thank you.
That was good. Any other question? Did that register, Alex?
Yes.
Cool.
Yes, very well. Thank you so much.
You're welcome, sir. Anybody else? Feel free. This is your time. Feel free. Get it now.
Can you explain exception handling?
Oh man, that's gonna be next section. But
okay.
That's okay. Exception handling basically refers to gracefully, okay? When you gracefully handle errors. Instead of letting the system knock or crash, you basically want to follow your exception with some kind of a polite, let's say a polite word, or try this do not work. So exception handling, but this is gonna be in the next section. So I'll be able to section 2, which is gonna be our next room section.
Okay, got it.
Yes. Any other questions?
Okay. Hello?
Yes, go ahead, please.
Oh, okay, I have 2 questions. One.
That John?
Yes.
All right, go ahead, man. Don't talk about fish, though.
Yeah.
Okay.
That's my bad, man. I'm not trying to be funny here. Go ahead, John. Anything you want.
So the first question is in reference to the third assignment you gave us, and it is more of attached to what Lucy was saying. So it was you assign as good credit to true. So that means that the has good credit means it's the variable that is holding the value true, right?
Yeah.
As per what Lucy explained.
Yeah.
Okay, that is the answer. Then the second part is, like you talked of the left associativity.
Yes.
And you said like our rule changes when some of the operators, when operators, some especially operators that exist that have got same precedence, like you talked about the multiplication
and the division.
So that those are the ones that have got same precedence.
The addition and subtraction, they have got the same. The division and multiplication, they have the same. So if you got them in the same block, you want to start from left to right. But the exception here is if you have like exponential, then the rule don't apply.
Okay. So
I'm sorry for cut you short.
Okay, thanks. Understood.
Is that what you wanted? All that's it?
Yeah.
So you don't want to talk about the fish?
Later.
All right, anybody else? Anybody, any question, please? I like this session. Very good. Feel free, please. Feel free to get your question in. How is the homework? Everybody feel good about it? Come on, Africans. It's fun. You know, do it now or forever keep your peace.
I struggled with Git, but I got it finally.
Oh, the Git? And that's right. Why would you struggle with Git? Git is just drag and drop.
I think I'm also struggling with that, but I have to try like several times for it to push.
Oh, dude, come on. Just if you can take your code into let's say into Colab, in the file in Colab, let me show you real quick so you can see.
It has helped me a lot with Git.
Yeah, you see here, hey, but sometimes you just want to walk. I mean, want to crawl before you walk. So here, this is a code, right? If you click on here, this is Git, this is Git like Google Colab, not Git, but this is Google Colab. Colab has a connection, and most of the IDEs do, but this is going to be easier. You start getting used to this one, and then you can always do another. If you click on File, you go to this one. You see here?
Oh, okay.
Yeah, and then you just click on that, and then it's going to give you another pop-up. And then for me, this is what I did with Dorothy today. So I'm going to save it under Dorothy, but it's going to be in my code. So in my Google, I have several repositories. Okay, so I can go ahead and let's say I want to use, let's say introduction to class assignments. And then I, basically what I do here, basically I go ahead and, okay. That screen, I don't like it. But hold on one second. Let's see. Okay, so I can go ahead and click OK, and then that will send it. Once I send it, then
George, you're not sharing. Oh, okay.
So it's gone, right? So once it's gone, now I'm able to see it here.
Okay, because we were using Git push.
You can do that, but at this level, you probably don't want to go that direction. It's
okay.
Overwhelming. Like it's command line, right?
Yeah.
Yeah, which is okay. It's gonna be coming very handy, but for now, just get used to this one.
Okay. Okay.
Maybe one day we get a way of making some video so that we can share. People can see how this is so easy. And then an option whereby you can just come here. Let's say you just want to go and upload your items to, let's go back here. I'm gonna go back here. I can't remember that, but hey, look here, you go to File.
Mm-hmm.
If you're in your Google, I'm sorry, excuse me. If you're in your GitHub, you look at, if you can see this, and then you're in your desired repository, go to File, right? Click on File, and then click on File Upload.
Okay.
Now here you can drag almost anything in there. Let's say I want to drag, let's say, let me go ahead and drag. I want to drag this one here. I can just drag and drop it.
Okay.
Drag and drop it, and then you come to commit changes. Always make sure, don't get excited and walk away. It's not yet saved. You have to click that, and then it's now going to be in here. Whatever I just uploaded.
Oh, okay. So commit is just like you're saving. Okay.
Yes, you gotta save it.
Okay.
So remember, you have to go here in your desired, because you might be having several repositories.
Mm-hmm.
My repository for this class, I say intro class assignment, and then I go here. I can go here, and then I say upload files.
Okay.
You can even create a file if you want to create a new file. Say, if you want to create software, I can just create that file, and then I go ahead and say, okay, that's a file I just created. I can review it, and then I can save it. But in this case, we are not going to save a file. So instead, we are just going to go back here. Hey, go ahead and leave. Okay, then we go back here. So from here, we go here, and then we upload it. Alternatively, you can go here, go to File, and then you can edit a file. Say I want to edit Dorothy. Yeah? Dorothy will be edited. I can edit Dorothy file from here. I can go into Colab from here straight. I can click on that, and then it takes me to Colab. And then I can put a little bit more code in there and then run it. If I'm done, and then it's gonna save it to GitHub. But I guess we need to put some video together for this, because maybe do it in Swahili.
Hi, George.
Yes, sir.
And
how about those who are using, sorry, how about those who are using Jupyter Notebook? Jupyter? Can you connect it direct?
if you're using Jupyter, you know, that's a good question, Derek.
Yeah.
They say when you're in Jupyter, which I do have.
Yeah.
On the
and
left,
George, I have mine open if you want me to share.
Go ahead and share.
Okay. So yeah.
Share first.
1 second.
George, there's non-Kenyans in the group, so so make the video in English.
Yeah, we're gonna make it
in English.
in English, right? Yeah. We'll do that.
Okay, so this is Monica sharing, and this is my GitHub.
Make your GitHub sexy like Monica's. Don't make it boring so that when people visit it, they want to come back. That's message for everybody.
All right, so I will go ahead and actually create a repository. And now how do you go to repository? It's right here after your account is set up, because I don't have any folder. Let me call this intro class lessons or notes, right? And then I'll make it public, and then I'll add a README file because I want to explain exactly what it is. Then I'll go and create the repository. And then, so here I am. I have my README file here. And just to give an intro of what it is. So this repo will hold all the PPTXs and Jupyter files for the class lessons. Okay, so I'll save that. So now I'll go back to my file. Here it is. I have this file that I've also shared on the blog. How do I get it to Jupyter? So you go to File and then Download As, Note IPNB. And when it downloads, this is a regular download. So guess what? It's gonna be in my downloads folder. So here it is. And if I wanna put it on my GitHub, so I'll come here, add files. And because I am just uploading it from my downloads folder, I can either drag it here or choose files, go to downloads, and here it is, and then open. And as George said, you have to commit your change. If you don't, it's like making edits to a document and never saving it, or having never made any changes.
Exactly. The best thing always, please try to make sure after you upload, go see if that link can be seen. If whoever you send the link to, can they see it? Because I get a lot of links which are blank, and I wonder, like, did they even check it?
Yeah.
And I always try to communicate back. I didn't see it. But make sure you check and be on the other guy's shoes. Can they see it?
And sorry.
And when George says to send the email, this is the link you actually send to his email. Like, oops, right. Yeah, you just copy this link, attach it to your email, because then it will point him to Mjaga intro class and not anywhere else in GitHub. All right. Yeah. And before you ask that question, let me add something else here. So he said to add a screenshot, right? Yeah. So assuming this is what I want to add in the GitHub, right? I would go.
I'm sorry. Make sure you give me a screenshot of that program running. So I can
yeah. Oh, yeah. Actually, let me do this.
But I mean, for everybody.
Yeah. Mm-hmm. So like, assuming we wanted to make sure this ran and so he can see the output, if he was asking for this, I would take that screenshot. Personally, I use this snip and sketch. So you just copy. And the one place to put screenshots is in your README. So those who are familiar with HTML, you can go in and put the code, but because I like the easy way, I just paste it there. And always make sure to commit changes. And guess what? Here it is. So when you send
how beautiful is that?
Huh?
That's beautiful, right?
Yeah.
Yeah. Man, that's it. Monica.
Yeah.
That's nice.
Now, Monica, my question is,
yes.
For example, you are downloading the notebook itself.
Okay.
What if you download with the Python extension?
With the Python extension, which one is
Python down there.
Oh, .py.
Yeah, you can do
Yeah.
it the same way, but it's not gonna be. It's not gonna.
Will there be a problem or it's just okay?
It's gonna be
the one. Go ahead, George. Sorry.
I'm sorry, Monica. Keep it. Click on keep it.
No, let's add here and see how it's gonna come out, because I know some of them. Oh yeah.
Keep it fast here.
Look here.
Down there. Don't discard it. The download.
Okay. Oh, keep it.
Yeah.
Okay. Okay.
So go ahead.
I'll go to the intro, add files, upload. And then here it is. And of course we save. And here it is. Yeah.
So to your question, is that Derek?
Yeah, my question is answered.
Yeah, your question, whichever way I can get it in Python, or we can also get in the other format, which is Notepad or Jupyter Notebook. Whichever way, I'm still IPYNB, I'm still able to open. Just make sure that you'd like me to be able to see your program running. Take a screenshot, and then with the corresponding source code, and then you send.
And just to add something, like this is when you're using Git to upload your file into GitHub. Like normally when you're using, there is always a difference. Like when you're using Windows and also when you're using Linux. So sometimes you can make comment, but and also connect to the remote server, which you created earlier, but it will always throw an error. So first you have to edit. There is a file called edit global config. So you have to edit your username of the GitHub and also your Gmail account, so that at the time you will be connecting to the remote Git, the remote server, which is the Git, it will prompt you to enter the username and the password of that Git, so that your repository is saved on your GitHub. So I think you should edit that. That's why you get that error.
Yeah. That's a very good point, John. And also this to everybody. If you can, you don't have to send only the program which is running. Send to GitHub as many programs as possible. Just put a ready and also comment your programs. The more you have your programs uploaded out there, the more traction you get. One day, if you are to go for an interview, say, hey, by the way, this is my GitHub account. They see a lot of activity in your GitHub. To that, in my head, translates like a very serious program. So if for some reason somebody is not doing GitHub yet, you need to start thinking twice, because GitHub is the pain. It's almost like, hey, we all speak English. Coders will speak different languages, but GitHub will combine us together. That's the lingua franca of the developers. That's where we go. It's almost like if I really want to see you real good, I'll probably go to LinkedIn. But if you're not LinkedIn, that's fine. Let me check you out in GitHub. The good thing is free. The second thing is free. The third thing is free. The fourth thing, so easy to work with. Don't just upload your images to me. It's old school. Try not to. If you don't, or if for some reason you're getting really stuck, I'm here. I'm here 24/7. You can text me, or you can send me an email, or you can actually even WhatsApp me. There are people in this group, probably about 5, 6. who have linked to them in Kenya or here, and I show them exactly. Not that I know it all, but we get to do it together. We have to do this. GitHub is a thing. When you say, I have a GitHub account, people start looking at you differently because they know, hey, this guy is really into development. Don't send me a screenshot in the mail, in the email. I might not even be able to see it because it will be buried in other junk mail. It might even go to the spam folder. So let's get this GitHub to be one of our lingua franca. That's how we all communicate. And you don't have to send me only when it's done. You can just say, halfway, just send it there. Maybe you'll pick it from there from another time. Make sure you put your comments and also put your reading part. Programming is just different. You have to get it together. When you're stuck, it does not mean that you don't know it. No. No. Yeah, we have to do it. So this is something we have to do real good and real good, real good, real good every day. Okay. Any other question, please? Anybody? Feel free, this is your time.
Yes, one more question.
Please.
On the, I think, third assignment, you had, the output was, the labels were in bold. Was that deliberate or? Because I had to do a little bit of a research to make the output, the titles to be in bold.
Which one are you talking about, Mr. Alex?
I think the third assignment where we had the output like name, and then let me take a look at it.
You can share your screen because I'm right now. You give me
I'm on a phone. Sorry. Okay. Yeah, the third one where we had the name, Kofi Olomide, country, profession, email, phone, country, city and address. I see the name, country, profession, email, phone, city, and address were in bold.
Can you share your screen? Can you do that?
Let me try. Give me 1 second.
Remember, the code was intentionally back. Did the code and I ran it, it worked on my side, and then I basically intentionally removed some stuff so it didn't work. So I want you to go ahead and fix that.
Okay.
So show me what you have. Are you on a phone? Are you on a phone?
Yep. Are you able to see it?
Yeah, let's try and see this. Okay. Okay. Apparently it's looking good. How big is the phone screen, man?
It's well, is this 6 point something? It's a 12, iPhone 12. Okay. Are you able to see the name?
Yeah.
Yes.
What's your question now?
So I was saying on the output, I see the name, the country, profession, email, and phone, city. Those are in bold, but the rest of them are not in bold.
Oh,
was that deliberate?
Don't worry about the bold.
Okay. Yeah, that's where the question was.
Yeah, don't worry about the bold. I was just making that to emphasize it. But so long as output, that's all I need. The bold, when you go, maybe when you guys come into advanced, we'll do some HTML, CSS, and some coding in, let's say, Django or Flask, and then you go.
Okay. All right. I see. Yeah, because I was able to get them in board, but I was like, was that part of the assignment, or was I just making my life difficult?
You can give me in bold, that's fine.
Okay.
Yeah,
all right.
That was not the intention.
Okay.
But if you can give me in bold, I would like to see your code. Maybe I might be able to learn something from it.
Okay. I think I sent it in bold. You can check it, review it.
I'll check it out. Alex, right?
Okay. Yes.
What's your last name, Alex?
Mandala.
Mandala. Okay, Alex, I'll check it out.
All right.
All right, thank you. Anybody else? Anybody? I hope this was very, very fruitful for you. I mean, like it's all recorded. In a few hours, it's gonna render, and then I'll upload it as is. I don't even edit. I put it out there, and then you guys get time and go through it. If you catch something you probably think we need to revisit, let me know. I'll be more than glad. But this is good. This is really good. And it really tells me a lot about the enthusiasm you guys have. And I'll work day and night to make sure that happens for you. Bombard me with questions. Python is so easy to learn, I can tell you that. After touching other languages, this is the easiest language. Okay. Okay. Any other question? John, you sure you don't have any question?
I have a question. Like, there is the assignment you gave.
One.
It was just a simple syntax. It was just saying the first print down payment. Then there was this print with a colon. So I tried to do some kind of research, but I wasn't getting the exact feedback. Maybe you can just
okay, which one? You have to show your screen because
let me show my screen. Okay, when I'm logged out. Just a minute. I'm logged out. When am I logged out? Just a minute.
Take your time, man.
Logged out.
So you can ask a question. If you cannot get it on, then I might be able to figure that out.
Okay.
Go ahead and just ask it. So what's the deal again?
It was just the last bit of print. Like there was no any string written on it. It was just a semicolon. Just what do I call it? It would be better if I show my screen so that I can check it.
Okay.
Just a minute.
So while John is doing that, I'm assuming now GitHub is almost something we don't see anymore. GitHub is going to be easy now. You can do the GitHub upload directly from your GitHub or just directly from Colab. But first you have to have a GitHub account, sign up and logged in.
Can you see my screen?
Yeah, I can see it.
So I was just asking these.
Oh, that's just a space.
Oh.
That's just to create a space. When you print it out,
yes,
that line is going to be left black.
Okay.
Yeah.
Okay. Okay. Thanks. That's what I was asking.
That's no problem.
Okay. Thanks.
Because sometimes you don't want to put everything in one, so you want to space them out for readability.
Oh, okay.
It's very easy. Really easy. But when you see like print and then we say a bracket and then we say F normally stands for format. There are so many ways you can format print format in your Python, and those will probably be most likely something we'll talk about when we get the third section of this course.
Okay. So.
All right. Anything else? Anything? Feel free, please. Feel free to. I'm not in a hurry to go anywhere. I'm here. Feel free to ask. Anybody else? Esther, you don't have no question? You sleeping? Maybe Esther's not in here. Anybody?
Are you talking to me?
Yeah, that's the only Esther I'm talking to right now. Esther?
No. I'm okay. I enjoyed the class. I actually learned a lot in the class.
Yeah, a lot of learning. After going through this, you come back again, you really rejuvenate some of the knowledge probably thought you've already captured, but you forgot.
Yeah.
And Nancy, any question? Now I'm going by one. I'm going to ask everybody almost. Anthony, you okay? Mr. Matoy?
I'm okay.
All right, good.
Yeah.
Okay, Dolapo is okay? Lucy Mutinda? Sevia? Laba? Everybody good? All right. Looks like everybody's good. So I'm going to go ahead and call it off. And I hope everything is good. And you guys have a good Saturday night. And for those people in the Sunday morning, good luck with that too. Thank you.
Thank you.
Thank you.
Thank you so much.
All right. Bye.
Bye.
Thank you. Bye.
Thanks.
Thank you.